Hello guys, welcome back to my channel Maison African Motives. Still working on O-level mathematics, still working on revisions and question papers and so forth, as we are preparing ourselves for the exams which are ahead of time, and we need to work on much as we can. So not wasting much of your time, we're going to focus on the question paper which was actually written November 2017, and it's paper 2. So we're not wasting much of the time here. Remember your instructions, you're supposed to read everything. These are the instructions for you. You are the candidate, so this is your information. So read everything, the instructions and so forth. And we had this paper, it had section A with 64 marks, and remember, in section A you have to answer all questions. That is everything that you're given there. So the first part, you're given to express or to evaluate 1,36 minus 7 over 8, and whatever that you're going to have, it must be given as a decimal. That is what you're given in this case. So you must be careful with such typical questions. It's easier for you. This is paper 2, guys, so it was easier for you to convert this to a decimal because your answer is needed as a decimal. Okay, so easily convert 7 over 8 to a decimal. So that means I'm going to be left with something like 1,36 minus, from your calculator, divide 7, because this is paper 2, you're using calculator. 7 divide by 8, you are going to obtain this decimal, which is 0,875, just like that. Then you can subtract also using your calculator. This is paper 2. With these stages, you are able to obtain all the marks. Okay, so that is what you're going to have in this case. On number B, we were given rectangle. It's actually a rectangle, and it's been cut here, and this is now a triangle, and it's not just a triangle, it's a right angle triangle, because this is 90 degrees and this is a straight line, so it means also this is what, 90 degrees here. So that means we have got a right angle triangle here. So the question is to calculate the perimeter. I want you to take note of the perimeter that they are talking about. It's perimeter of A, P, Q, that is A to P to Q, then RB, from R here to Q to R to B. So which means this part is being left out. You are moving this way from P to Q, from Q to R, then from R to B, from B to C, then C to D. So which means we are supposed to know this distance of QR, this one. So how are we going to know this distance? Okay, I want us to put this triangle like this. Okay, this is our triangle, this one. I want us to put it this way. Okay, this is what we have, something like this. This is your P, this is your Q, this is your R. You are not including this distance, this one. It's not involved on your perimeter. If it was A, B, C, D, like that, then that is why you take this side. But it's from P to Q, then Q to R. And you know that this is 3. What about this? We do not know. But the only thing that can help us is to find this side, even though we are not going to use it on the perimeter, but it can help us to find this missing side, which is that side. So how are we going to find this side? Because we know from D to C is 10, which means from A to B it's also 10 here. So if this is also 10, because this is a rectangle, so it means I'm just going to add this 4 plus 2, which is 6, and from 10, that is 10 minus 6, which is 4. So which means this is 4 centimeters. Okay, so this is 4 centimeters. And by that, it's now easier for me to find QR. Why? Because I can simply use what? Pythagoras theorem. A squared is equal to h squared is equal to a squared plus b squared, which means our h, which is QR, that is our hypotenuse, QR squared is equal to 3 squared plus 4 squared. And remember, I also talked about Pythagorean triples. The moment you see that 3, 4, know that the other side is also 5. But if you don't know that, then you have to apply your Pythagoras theorem. So this is going to be 9 plus 16, okay? 3 squared, that's 9, 4 squared, 16, and 9 plus 16, which is 25. So it means QR squared is equal to 25. What is the value of QR? Introduce the square root on both sides. So that means our QR is 5. So that means here we've got 5. Here from Q to R, this is 5. So our perimeter now is going to be easy because we need the perimeter of A to P, that is A to P, which is 2, okay? Plus P to Q, that is P to Q, which is 3. Plus Q to R, that is Q to R, this one, which is 5. Plus R to B, which is 4. Plus B to C, this one, B to C, which is 6. Plus C to D, okay? C to D, which is in this case is 10, okay? And the last one is D back to A, which is D back to A, this one, which is 6. So that is your perimeter. Perimeter is distance right round the shape. So it's right round the shape that you're given, this one, right round it, right around the shape until this. Okay, so that's it, guys. You simply add everything from your calculator and this will give you 36 centimeters. Perimeter is just centimeters, it's not area. Area, that is the one that you measure in squares, centimeters or square meters, something like that. But here it's perimeter, just the units as they are. So that's how you simply have to answer these typical questions. And I think something that was direct, if you are to take a closer look, let's see on 1C. Item 1, we are asked to factorize completely x squared minus 6x. So sometimes these are just like questions just to, they'll be like trying to check, do you clearly understand your factorization concept? Like, can you just factorize? Because this is x, which is common, so just factor out x. X squared divided by x, that's x minus 6x divided by x. This will give us what? Minus 6. Remember, you simply have to divide the part that you're given, just like that. Okay, so that's it. And here factorize is m squared minus 1, m minus 1, sorry, squared minus 9, like this. Okay, so what type of an expression? If I'm to check this, it's a difference of two squares. This bracket is being squared, and this 9 can be written like m minus 1 squared minus 3 squared, like that. It can be written like this. 9 is same as 3 squared. Square root of 9, which is 3. So which means, and that means 9 is same as what? 3 squared, vice versa. All right, you know that is a plus or minus. So this from, remember guys, I told you that a squared minus b squared, as long you can write this in terms of squares, it's a plus b, a minus b. So in this case, this is our a, which is m minus 1. The other bracket is going to add 3, okay, m minus 1, this one, okay, a plus b, a, this is your a, and this is your b. So this is your a, and this is your b. So it's a plus b. So you can even write it like in bracket. It's one and the same thing, okay, into a minus b. This is my a here, which is m minus 1 minus b. My b is 3, just like that. So this is how you can write it. But can I just leave my answer like this, guys? Definitely not. I have to collect like terms, okay, because you have minus 1 and 3. So if I add this, I'm going to obtain 2. Minus 1 plus 3, that's 2. Minus 1 minus 3, which is minus 4. So at the end, I'm going to obtain that is my final answer. So easier, as we can see, it's a matter of understanding what you're given in this platform. So another part, we are asked to simplify or to express this as a single fraction. Okay, so as we know, guys, the first thing is to have is the LCM of the given two denominators. We've got v minus 3, v minus 2. So it's v minus 3, v minus 2. All right, so you have to divide this LCM or our LCD, divide by the first bracket. So as you can see, v minus 3 and v minus 3 will cancel each other, but you don't cancel, you are just assuming cancelling these two brackets. So which means you'll be left with 3 times v minus 2, because these two have cancelled each other. Okay, minus, you divide again this LCD, divide by v minus 2, v minus 2, v minus 2 cancel, which means you're going to be left with v minus 3. So it's minus 2 into v minus 3, just like that. So at the end, it's a matter of expanding brackets so that you can be able to collect like terms. So what do we have here? 3 times v, that is 3v. 3 times minus 2, that is minus 6. Okay, take note, negative, guys. This negative is affecting everything. So it's minus 2 times v, which is minus 2v. Minus 2 times minus 3, which is a plus 6. And it's everything over. Don't leave the denominators here, which is the denominator that you're given, the LCM. You have to write as it is throughout. All right. So that means here 3v minus 2v is going to give us something like what? 3 minus 2, that's 1v. So 1v same as v. Minus 6 plus 6 here, that's S0. So this one you can write just plus 0. Okay, then just for the case of everyone to understand. So this is simply same as v over what? V minus 3 into v minus 2. It's just one and the same thing, guys, because if you add 0, it's like 2 plus 0 is just 2, 3 plus 0 is just like 3. So that is the same thing. So there we are being asked to express as a single fraction in its simplest form. That is a single fraction in the simplest form. So you have to check here. We can't even divide anything, just leave it like that. Okay, so that's what we had on this particular question. Let's see question 2a, item 1. We are given 3 interior angles of a hexagon. Take note, this is a hexagon, and you're talking of a hexagon having 6 sides. Okay, so they are saying 3 angles, they are each x degrees, and the remaining 3 angles are each y degrees. Form an equation in x and y that satisfies this condition. Form an equation in x and y that satisfies this condition. Okay, we are referring to a hexagon, guys. Okay, we are referring to a hexagon, and this is not just a hexagon. We are referring to interior angles of a hexagon, and we know, guys, that interior angles of any polygon that we have can be given by this formula, n minus 2 times 180 degrees. Remember, I talked about this on polygons. So this is a hexagon that we have, which has got 6 sides. Okay, so simply meaning to say we can find the interior angles by substituting the value of n, which is 6, then we can multiply by 180. So doing this from a calculator, because this is going to give us 4 times 180, this one, which is 720 degrees. So which means this polygon on the interior angles, when they are added together, they add up to 720 degrees. All right, now we are given that 3 interior, which means each is x, and there are 3 of them. So which means we are going to have 3 times x each. So it's 3 times x plus we have other remaining 3 again, which is each y degrees. So that is 3 times y, and which means all the angles that are there, because these are 3 angles combined together plus 3 to make them what? 6. So the total of these interior angles should give us what? 720 degrees. Take note, these are interior angles, not exterior. If it was exterior, you were going to equate to 360 degrees, because we know that exterior angles of any polygon that up to 360. But these are interior angles, so you add to the equivalent of that polygon. All right. Now I have to simplify this further. I can just reduce by what? By 3, by 3, by 3. Okay, that's gonna be x plus y is equal to 720 divided by 3, which is going to give us 240. So we have formulated an equation. We just have to leave it like that. All right. On number item 2, we are now given also 5x is equal to 7y. Use this equation and equation in item 1 to find the values of x and y. We are now given another equation. So this is like simultaneous equations now, because on item 1 we obtained that x plus y is equal to 240. This is what we obtained from item 1. Now they are saying 5x is equal to 7y. Solve this equation. So you can actually solve no matter the way that you find it best for you. I don't know, but it's just a matter of arranging. You can make x to be the subject here, then substitute on this one. I don't know which method is best for you, but as for me, I'm just going to use this one, because I think all these methods I have explained them. Okay, so this is equal to 240 degrees. I'm just going to transpose this to this side, so it's going to be 5x minus 7y is equal to 0, like that. So it can be just a normal equation like the ones that we are used to, so we can just eliminate using elimination method and substitution together. We can make this same as 1, so we can just interchange to make these two to be the same. So multiply by 5 on top, multiply by 1 below there. So it's simply you're multiplying each term here by 5. This is same as 1 also. So it's 5 times 1, that's 5x. 5 times 1, which is 5y, which is equal to 5 times 204. This is paper 2, so you're not even supposed to worry about this, because your calculator is going to give you the answers there. All right, so that is what we are going to have in this case. So multiplying this by 5, we are going to have 1200. Okay, then here it's 1 times 5, which is 5x. 1 times minus 7, which is 7y, is equal to 0, like that. So I can easily eliminate or remove this x, because now they are the same. So just subtract, okay, because it's 5 positive and positive, remember, you can eliminate this. So 5 minus 5, that's a 0. 5 minus minus, take note, there's a minus and a minus, so it will be a plus. So it's 5 minus minus, like this, which is going to be a plus. So it's 5 plus 7, which is 12. Y is 1200 minus a 0, which is 1200. So you can divide by 12 by 12. That means y is equivalent to 100. That is what we are going to have for the value of y. And to obtain the value of x, we can easily substitute here, or whatever the way you want to find it. But I can easily work with this one, because I know that x plus y is 240. Y is 100, so x plus 100 is equivalent to 240. So I can easily transpose this to the other side of the equation, which is 240 minus 100, because we have crossed, if whenever you cross the equal sign, the sign also changes. So it's 240 minus 100, which is what? 140 actually. So your x is going to be 140, just like that. So these are typical questions that we have, and we must be very, very careful how we attempt these questions. It's a continuation from another question that you had, and simply like that you can solve. And on number 2a, we are now given a circle that is okay, let's just see what we're given there. We can actually make some adjustments, because this is O, which is the center of the circle, so we can easily maybe join this, so maybe it can make some sense. Okay, I don't know if this part is going to be clear, but let me just try to join with this side. Okay, so just join like that. In that part here, we are given some information that is important. The diagram shows point A, B, T, that is A, B, and T on the circumference of a circle. Center also, this is the center of the circle. That is from O to B is the radius, O to T is the radius. So what do we know? these two are equal, that is the radii. The radii are equal. OT is equal to OB. That's the radius. Okay. Then we are also given that PT is a tangent. So also take note, guys, whilst you are reading this information, some of the things you must be able to indicate also on your diagram like this. PT is a tangent to the circle at T. This one, PT is a tangent. So remember that an angle between a tangent and a chord, angle between this tangent PT and the chord AT. So you hold this chord AT. I want you to take note about this theorem, is equal to the angle in the opposite segment. So what you do, that you hold this chord AT. Okay, where is it going? To the circumference of the circle. Let's go with it to the circumference of the circle. It goes at this point B. So this point, this angle here at B and this angle here, they are equal. Angle between the tangent and the chord, this chord AT. So you hold it, to hold that chord with it to the circumference of the circle, where it creates an angle to the circumference of the circle. That is where it is equal. Okay, so that is the case. And also we are given that AB is parallel to TO. AB and TO, they are parallel. So from that, are there theorems that we see? Yes, they are there. We know that this is a Z that is created alternate angles. Look at this. We are creating a Z here. This is a Z that is created. So this angle here at T and this angle at B, they are equal. Alternate angles, the ones that create a Z, they are equal. So this angle here, this angle here, and this angle, they are equal, all these three. Why? This one, we saw it from a tangent and a chord, and this one, we saw it from alternate angles. Also, because we said OB and OT, they are equal, that means this is an isosceles triangle. This angle here and this angle, they are equal. These are base angles. So it means this angle, this angle, this angle, this angle is just one angle. Once you're able to obtain one, you're able to know all these. Okay, so the first question is name two angles equal to ABT. Okay, ABT. Now you look at this question, it's asking us this. So you see, knowing your theorems, it becomes easier even to answer questions like this, because already you know that ABT, we said is this one. So it's going to be PTA. I don't know how you are going to write this one. You can write it as PTA or you can write it as ATP, no matter the way, ATP, like that. Okay, what is important, that T is the angle that you are referring to. Okay, and also this one you can write it as OTB or BTO. I don't know the way that you're going to write it, so here I'm just going to write it as BTO. This one you're not going to write it because it's an adjustment that we did from a diagram. Yes, you can write it, but this one TBO. Okay, TBO, this one from T to B to O, but this one is just an adjustment because we never had it on our diagram. Remember you to construct this side. Okay, anyways, these angles, they are equal. So I think I explained each angle, how it is equal to another, how it is equal to another. I explained all those theorems. Okay, anyways, let's just calculate BAT. So calculate BAT. BA to T, that is this angle. So let's indicate with another one because it's not the same with other angles. So I'm just going to indicate with an like this. So this is your BAT, this angle here. How can we find this angle, guys? How can we be able to find this angle here? Okay, this is what you're going to do. Actually, it's in fact you're supposed to use the angles as they are. Yeah, like we say this angle here, we can't find this angle direct. This angle here, we can't find it direct. Okay, but we know that this angle here and this angle, they are equal, and also they are equal to this. So we can at least find this angle, the one that is unknown, the one that we are just saying, the angle that is equal to this and equal. So how can we find that angle? Okay, we know that here this is a radius and a tangent. Okay, a radius and a tangent here, they meet at what? At 90 degrees. This one, a radius and a tangent, they meet at 90 degrees like this. All right, so if they meet at 90 degrees, and we know that this is 40 degrees, this one is 40 degrees. So it means if I am to add this angle ATP, let's say it's x, because it's the same as this, we just say it's x, this one, because these angles, they are the same. Remember, we said they are equal. So let's say this is x. So this x here plus this 40 degrees plus this also x, because they are equal. So I'm just putting them as x. They must give us an angle of what? Of 90 degrees here, because it's a theorem that we are saying a tangent and the radius, they meet at 90, and all these three, they are creating this 90 degrees. So it means I can be able to calculate x, which is this angle. If I'm able to know x, which means I also know this angle. So x plus x is 2x, and transpose this to this side is going to be 90 minus 40, which is 50. Then divide by 2 by 2, that means our x is 25. So this angle here is 25 degrees, which means this also is 25 degrees. This also here is 25 degrees. And that means it's now easier for us to calculate what? To calculate BAT. Why? Because we are referring to angles inside a triangle that we know they add up to 180 degrees. So to find BAT, I'm going to subtract now these two angles which are inside this triangle, because all these three angles, they must give us 180. So let's subtract this 40 degrees and this 25 degrees. So we've got 40 degrees plus 25 degrees. Subtract these two from 180. That means we are able to find the value of BAT, which is minus 65. So subtracting properly, we are going to obtain 115 degrees. Okay, so actually there are so many ways that we could have done this. That one or those ways, I need them from you guys. If you give any other way that we could have used to have or to determine our BAT, let me know, guys, on the comment section, so that we can have different ways and approaches in the next future. Okay, but that's what we had from this particular question. And the other one is to make to express a in terms of x in terms of a and b, that is to make x to be the subject of the formula. Simply make x to be the subject of the formula. There we are given that ax is equal to the square root of b squared minus x squared, and they're asking us to make x to be the subject, that is to express x in terms of, simply make x to be the subject. How is that possible? How is that possible? Okay, the first thing is we have got x here, we've got x here, and this is under a square root, this part, so we have to work on it to remove this part under the square root. How is that possible? We can easily square both sides, isn't it? We can just do this, both sides, we square both sides, and if we are to do this, that means this is going to be a squared x squared. You square each and every term, a to the exponent of 2, x to the exponent of 2. Okay, but on this side, remember the purpose of squaring both sides was to remove the square root. So it means this is no longer there, this square root is no longer there. The purpose of you squaring like this was to remove the square root, so it's no longer there. You have actually neutralized everything. Okay, now I can clearly see the part that has got x, and I can transpose, because they are now free to move or to be transposed to any part of the equation. So here I can transpose this to the left hand side, and that will be a squared x squared. It's a minus x squared, so once it gets to this side, it will be a plus x squared, which is equivalent to b squared. This is true. We've got x here, so you can easily factor out, because there are two. So factorize or factor out x squared. That means ax squared divided by x squared, this and this will cancel. These two, they will cancel. So which means you'll be left with a squared plus x squared, and x squared will cancel. So which means you're going to be left with 1. equal to b squared. So divide by the bracket, that's a squared plus 1, divide by the bracket a squared plus 1. So this can cancel, and our x squared is equivalent to b squared over a squared plus 1, simply like that. So I want to make x to be the subject, not x squared. So how is that possible? Introduce the square root, guys. It's the opposite of what you did here. You removed the square root by inserting the square. Now you want to remove the square, so you have to put the square root. It's just the opposite of what you did. And this time you must be able to note that the square root of any number is a plus or minus. So therefore our x is going to be plus or minus. Yes, here on the numerator I can find the square root. Remember from your laws of sets that you can separate anything that is in set form, that is anything that is under the square root, dividing. So you can find the square root of this b squared, which is b, over this part. We can't determine its square root because it's an expression, so it has to remain under the square root, which is a squared plus 1, like that. Or you can even leave it like that, under the square root plus or minus the square root of, but this can be much better presenting your answer, your final presentation, or your final answer. In that way it can be much better way of doing it or expressing your answer. So actually that's what we had, guys. It's a matter of following the stages or the steps that you are given, just like that. Okay, so anyways, let's see the other question. On number 3a, we are given the matrix P, and they are asking us to state the order of the matrix. So guys, this is a simpler question. Remember, matrix, the order is row by column. So how many rows? We've got 1, 2. So it's 2 rows times how many columns? 1, 2, 3. So this one is a 2 by 3 matrix. Okay, then calculate q squared. So q squared, that is what we need. So this is number 3a, item 2, 1, like this. Okay, that's it. 3a, item 2, then 1, which is q squared. So q squared, you're simply taking this q, then we square it. Okay, so how do we square it? That is the question. Minus 2, 3, minus 4, 5. This is our matrix q. Now we have to square that. So to square simply means it is multiplying itself, just like that. Just like 2 squared, 2 times 2, 3 squared is 3 times 3. So q squared, it's matrix q times matrix q. So we can easily perform our matrix multiplication, which falls under row by column. So it's going to be row by column, which is minus 2 times minus 2. That is 4. Minus and minus the plus. Okay, plus here 3 times minus 4, 3 times minus 4, which is minus 12. Okay, you are done with this row and this column. You move on to this column, still under the same row. So you have to write under this column now, because you are now on this column. So this is minus 2 and 3. So it's minus 2 times 3, which is minus 6, plus 3 times 5 here, which is 15. So I'm done with this part. I have to go down now to this row. I'm now working with this row here, a row like this. Okay, column. Okay, so it's now this row, and versus the first column as we did in the first place. So it's minus 4 and minus 2. So minus and minus, that's a plus, so it's 8. 5 times minus 4, it's a minus. Yes, we have the plus to say we are adding, but 5 and minus 4 gives us minus 20 if we multiply these two. Minus 4 and 3, minus and a plus, that's a minus. So it's minus 12 plus 5 times 5, which is 25 in this case. So easily at this stage we can actually collect or work with our like terms. In fact, just simplify. It's not about like terms actually here. Just combine plus and minus. It's a minus here. So it's 4 minus 12, which is minus 8. Okay, minus 6 plus 5 plus 15, which is 9. Okay, 8 minus 20 because it's plus and minus, so it's going to give us a minus. It's 8 minus 20, which is minus 12. Minus 12 plus 25, which is 13. So this is paper 2, guys. You can even simply use your calculator to do all these. So anyways, that's what you're gonna have, and you have to be very, very careful with the presentation that you have. Okay, the other part, which is on 2 now, that is 3a item 2 and 2. Calculate q to the power minus 1. So q to the power minus 1 simply means the inverse of what? Q. So how do you find the inverse of a matrix? Remember, to have the inverse, all we need is to first have the determinant of the matrix. So it's actually, this was our q here. I'm just going to write it down because at least it can help me to explain this part. Okay, so the first thing, like I'm saying, we have to find what? The determinant of q, which I said it can be just determinant of q, or you can write it like this. That is the determinant of what? Of q, which is equivalent to AD minus BC. That is A, B, C, D, like this. So it's A, D minus BC, just like that. If you can write your matrix in that order, then you can be able to use this. So that means the determinant of matrix Q is going to be A times D, which is minus 2. That is your major diagonal, the product of the major diagonal minus the product of the minor diagonal, which is 3 times minus 4, simply like that. Okay, so minus 2 times 5, that is minus 10. Minus 2 times 5, that's minus 10. And yet minus and minus, which is a plus. 3 times 4, which is 12. Okay, so we can combine these two, minus 10 plus 12, which is 2. So that's our determinant. And we know that the inverse of Q now is given as 1 over the determinant. Remember, it's 1 over the determinant. And what you're supposed to do here, this A and D, remember they interchange the positions. So it's going to be 5 minus 2. And the minor diagonal, which is this part, you multiply each by minus. So it's 3 times a minus, which is minus 3. Minus times a minus here, which is a 4. So that is now the inverse. So you simply multiply every term in the minor segment by a negative. And what is on the major part, which is the A and the D, you have to be just interchange the position of what, of those numbers. It can be, sometimes they can give these as letters, or they can be as numbers like this. You just need to interchange them. All right, for number 3b, we are now given that it's actually a variation. B item 1 given m varies directly as the square of r and inversely as the square root of h. So this is a joint variation. We are given two things here: directly as the square of r, inversely as the square root. So how do I express this? Okay, how do I express this? M varies directly, which means we just have to combine everything as it is. Sorry, let me just try to adjust this side. So here is a direct variation that you are given, that is the square of r, like this. That is a square. Okay, then the square root is the other way, it would be given like this. That's the square root. So this one is the one that is inversely as the square root of h. So which means h is under the square root like this. Inversely, remember I told you that it's 1 over, so that is how it's going to look like. So now we are asked to express m in terms of r and h and a constant. We are told the constant to use here, which is what? Which is k. So we are going to introduce the constant that you are given. So m is equal to k r squared over the square root of h. So that's what we had in this case. And find the value of k. We are now given that r, h, they are equal, and m is 14, it's 12. So find the value of what? The value of k. So we are simply substituting this information. So you can even put it aside so that at least we cannot lose much track here. All right, so it's just going to be a continuation from this part that we are given. Since we are given that m is equal to k r squared over the square root of h. I'm just going to substitute the values m. We have the value of m here, which is 12. So 12 is equivalent to r squared, which is r is equal to h is equal to 4. So it's going to be 4 squared. So that's 4 squared times k, everything over square root of h, which is square root of 4. Remember, these two, they're equal, r and what? And the h. So we can simplify further, which is 12 is equivalent to 4 squared. That is 4 times 4, 16 times k over the square root of 4, which is 2. So here, we are not focusing on the plus or minus, we just use the positive value. Okay, so you can reduce this 2 into 16, which is 8. So that means 12 is equivalent to 8k. So you can divide by 8 both sides, so that I can obtain the value of k. So on your calculator, if you are to divide this, it's going to give you 3 over 2, which is same as 1.5. So this one is just a constant value, so you can leave your answer like that. K is 3 over 2, just like that. Okay, so that was the question, guys, and you'll be like, okay, just like that, 2 marks. So that's what we had, and it's done like that. So guys, please read and understand the questions. Don't panic. Okay, don't panic when reading this. It's variation, then everything goes astray, something like that. Okay, then we are given for number C that there's a, so this is scalene that you're actually given. It's a right angle triangle. Remember, scalene, guys, the sides, they are not equal. Okay, so you're just going to put this way. It's a scalene. Remember, the sides, they are not equal, so it's something like this. All right. Okay, so let's just say this is where we've got our 90 degrees, and it's A, B, C. Okay, so remember, this side and this side, they are not even equal, and this side, they are not even equal. Okay, now we are being told to write down the special name of the quadrilateral that is formed by triangle ABC and its image. So its image, if it is a reflection in the line of what? AC. So this is a reflection of line AC, this one. Okay, so definitely we know that if it is a reflection, this point is going to move to the mirror line. This is like the mirror line. Each and every point, like let's say it was like this. Let's just continue with this line like this. Let's say we had a graphical presentation. Okay, this point, this is where you're having your mirror. So this point is not going to move anywhere. It's going to remain where it is. This one is going to remain where it is. But this point is going to move in such a way that the distance that it takes here from this point to the image, which is the image line, this one, it is going to create 90 degrees and have the same distance like the one that it has. So if it is 1 unit like this, it goes 1 unit, which is the same way if it was from this way. If it is to move like, I don't know how many units are there, it is going to move the same on the other direction. So that is the concept that you are actually having there. So that's somewhere, let's just say somewhere here, and also this part, it can be somewhere there like this. So actually you'll see that this is like your mirror here. So you're actually putting this maybe a certain distance to this point, and it's the same that is moving here. So this distance that is being moved is between these points. So it's like this is your B1 and the C, everything they just at this point. And if you are to cross check, remember your concept of joining corresponding points that you're going to produce parallel lines. You see that we are even producing parallel lines. So what is the shape that is going to be created? Remember, this side and this side will be equal, this one and this one will be equal. So it's actually a rectangle that we have created there. Okay, what if it is a rotation of 180 degrees about the midpoint of AC? The midpoint of AC, this is where our midpoint is. So if it is a rotation, remember the concept of a rotation, that all points, they have to move, and the way that they move, if it is, remember, a rotation of 180 degrees, it's a special type of rotation. I actually explained this in our classes when I talked about this type of rotation, where all points are going to pass through that point, which is the center of what? The center of rotation. All the points, they'll pass through that. So here, if we have a triangle like this, let's say this is our right angle triangle, because this is not like equal, but all that we know is that if this is A, B, C, because this is right angled here, if this is the midpoint here, this point is going to move equal distance from this point here to this point, okay, then to the image. So here is the same, so your C is going to be seen on this point. This will be your C1 and this will be your A1. Your B is going to move the same. The number of units here is the same that is going to have, so which means this is going to be your B1. So the shape is going to be like this actually, like, but this is A1, this is C1. But at the end, what shape are we creating here? That is what is important. What shape are we are going to create a rectangle, because this will be at 90 degrees definitely, because it's just the same way or the same procedure. If you say it's different from how we mapped this C1 remained where it was, A1 remained what, but B was the one that was reflected to the other side. But at the end, what is the shape that is created? That is what is important. Yes, this is now your A1, this is your C1, your B1, but at the end, what shape are we creating? It's a rectangle. The image and the object combined together, they are creating what? A rectangle. So that was the important part about this. So this is your item 2, which is a rotation of what? Of 180 degrees about AC. And okay, the number 3 already did this part. So it's actually, see, 1 mark. They just want you to know like the basics of this rotation and the concept like that. Okay, so that's what we had actually. We move on to number 4, which is actually on sets. And there we are given the Venn diagram shows the universal set, which is the universal set, and its subsets A, B, C. The number of elements in each region is shown. Find number of elements in B. Okay, so this is your set B, this one. So the number of elements, you simply have to add everything in this set B, combine everything together. Okay, so that is your 4, item 1. So the number of elements in set B, combine everything that you see in that set, which is 7 minus x plus this x here plus this 6 here and 5 plus 6 plus 5. Okay, this 5 here, everything, you just close this set B, you add everything in that set. Okay, so as you can see, minus x and minus and plus x will cancel and it will give us a positive. So 7 plus 6 plus 5, and this will give us 18. So these are the number of elements in what? In B, because this is simply 11 plus 7, that's 18. Okay, so that's what we had, and we move on to another question. Find number of elements in A complement intersection B intersection C, where A is where A complement of the set. Okay, so where actually do we have this part, guys? A complement. Okay, A complement, we are referring to the set that is not in A. So this is, we close this part here, like this is our set A. So A complement, we are left, I want you to see the part that we are left with out of A complement. We are left with this part here, okay, this part here, this part here, and this part. This is your A complement. What is not in A? Okay, this part that we are talking about, this part, it is intersection. Now I want you to see what is happening. Intersection B, intersection C. So let us focus with this part here of B intersection C. Like, what are we going to have on the intersection from this part that we have now and going into intersection of B and C? So the intersection of B and C, this is your B, C. The intersection of B and C, we are referring to this part. This is your intersection of B and C, this one. So I don't know if it is not going to affect the other page there, but this is your intersection of what? Of B and C, this one. So now we are saying of all these elements, which part are we going to remain with that is going to affect this part now? Because remember, your A complement was this part, and this part, and also this part. So what are you going to have? Because B intersection B, this is B intersection B, this one. So the intersection of both, what are we saying? This part here, this 6, it was there on the A complement. It's also there on the inter. So this is the part that you're going to remain with, which is 6. So in this case, your answer is going to be a 6. That's what you're going to have at the end. Actually, what you need is to understand this, like the information, how it is presented, guys, from a diagram like that. Okay. Anyways, on other item, we are now given to find the number of elements that we are going to have in what? In a set. Define the value of x given that number of elements in A is 23. Okay, the number of elements in this set A, this is your set A, is 23. Then find x. So you simply have to add everything in this A, because that is what you're given. Everything in A, equate that to 26, just like that. Is it 26, 23? Okay, this is A item 3. Okay, so you're given that number of elements in set A is equivalent to 23. Okay, so I'm going to add everything in this set A because it's equal to 23. So I've got 12, 7 minus x. So it's 12 plus 7 minus x plus this x here plus this 8 minus x. Everything I have to add, equate it to 23. So it's actually like working with the information that you're given, then equate to the numbers that you're given, which is 23. So you can formulate an equation like that and you can solve for x. So take note here, it's minus x plus x, which is a 0 here. So you can add 12 plus 7 plus 8, and this will give us 27. It's going to give us 27 minus x, which is equal to 23. So you can simply make x to be the subject, whatever way that is important. I don't know which one is good for you, but you can easily transpose this. It's minus 27 here. So 23 minus 27, that's minus 4. I can divide by minus 1 both sides. Remember, I want to calculate the value of x, not minus x. So this can cancel, and my x is going to be a 4. So in this case, that's what you're obtaining as the value of x, which is 24. Okay. On B, item 1, we are asked to find the gradient of the line, which is given by the equation. Remember, I also explained about these typical questions when you are given the equation of a line, 4x, it's not 4x actually, it's 4y there, minus 3x, which is equivalent to minus 8. Whenever you are given an equation of a line, if you are able to write it in the form of y is equal to mx plus c, it means this m is what? Is the gradient. So all you need is to make y to be the subject of the formula. How is that possible? So let's just transpose 4y is equivalent to, I can transpose this x to the side of the equation, that is the right side, and it's going to be a positive 3x minus 8. So simply divide by 4 by 4 by 4 each and every term. That's y is equal to 3 over 4x minus 2. So this one, whether I simplify or not, but what is important is this part here, which is this part here, which is this part here, the part that is affecting x. This part is the gradient of the line. So our gradient in this case is actually 3 over 4. So the gradient is simply the value of m if you are, or if you have expressed your equation in the form of y is equal to mx plus c. So that's simply the gradient of the line, and you are given now to find the coordinates of the point where the straight line crosses the y-axis. Okay, whenever the line crosses the y-axis, it means x is equal to 0y. That is your y-intercept. Okay, this part, guys, you may have to revise this. Okay, this is my Cartesian plane, this is my x-axis, this is my y-axis, like this. This is the part where the line crosses the x-axis. Okay, at this point y is equal to 0. Along this whole line y is equal to 0, and here along this line x is equal to 0. So this is your y-intercept where it crosses the y-axis, where it crosses the x-axis. So you can simply use this information in future on any type of equation. So here they're saying where it crosses the y-axis. So in the y-axis, x is equal to what? X is equal to 0. So knowing that x is equal to 0 can be an advantage now into this equation. Already we have made y to be the subject. Yes, we have made this and we obtained y is equal to 3 over x minus 2. So when x is equal to 0, like this, it means y is equal to minus 2. So that means the coordinate now is 0, minus 2 as a point like this. So that's what we had at the end of this platform. Now take note here that we have got the item 3 now, which is to find the equation of a line that is parallel to the same line that we were working with, the line of 4y minus 3x equal to minus 8, and this is passing through this point which is 0 minus what? 0 minus 3. So here what do we have actually? Okay, the first thing that we know or that we are given is a point. Okay, that is what we are given. We are given a point 0, 3. Okay, this is B item 3. So we are given a point, which is this point, and it is parallel to what are we having here? Parallel to, this is the part that you're supposed to take note from there. Parallel to means the two lines, they have got same or equal gradients. So which means if I am given the first line, okay, and the second line, these two, they have got same gradient. Remember I told you that M indicates or represent what? Gradient. So what does it mean? It means I have to go back here because it is the same line, this one that we worked with before. This one, it is the same line that we had, and we obtained a gradient of what? Of 3 over 4. So it means I am going to take this as my gradient because we are saying the gradient is the same. So here the gradient is there, which is 3 over 4. That is our gradient. All right. And also the other thing that is very, very important is that this point that we are given, which is 0, 3, as we can see, if you are to take a consideration, remember I told you guys when x is equal to 0, it means you are in the what? You are in the y-axis. In the y-axis here, x is equal to 0 throughout. So which means this point is 0, 3. It actually indicates, or that's our y-intercept. So it's not like this to say when you are given a point 2, 3 like this, then you say this is my y-intercept. No, that one is not. When your x is equal to 0, that your y-intercept. Okay, like this one, x and y here. So x is equal to 0 there. So we can easily take that as an advantage, since we know that y is equal to what? Mx plus c, where m is the gradient. So that means y is equivalent to the gradient now, which is 3 over 4. So we've got 3 over 4x plus c, which is the y-intercept. So the y-intercept is the value of y when x is equal to 0, which is the value of y is what? Is 3. So that will be our equation. So you can actually use that part of working with a point. It doesn't mean it was going to give us a wrong answer. No. Let's say you wanted to use the longer concept, y is equal to mx plus c. Then you substitute your m, which is the gradient, that is 3 over 4. So y is equal to 3 over 4x plus c. Since you are given the point 0, 3, you are going to substitute this point. This is your x, this is your y. So y is equal to 3 when x is equal to 0. So it's 3 over 4 times x, which is 0 plus c. So that means I am able to determine the value of c from this equation. So this times is 0, it's any number times a 0. Remember it says 0. So 3 is equal to c. So if 3 is equal to c, that means y is equivalent. I'm now going back to this stage here where I am given 3 over 4x plus c, which is 3. So that is going to be the equation now of the line that is parallel to that line. So I think it was a little bit clear. Let's see the other part that we were given. Now we are given that there is a jug which is 20 centimeters high and has got a capacity of 125 millimeters when full. So this is a jug that we have, and whenever we are given capacity, we are referring to what capacity. This is volume, this one capacity. Okay, so whenever you are given capacity, you are given volume. Okay, so the question is to calculate the height of a similar jug which has got a capacity of 1 liter when full. Okay, so here what are we given? We are given the capacity, which is the volume of a jug, or just like volume of a container, and the height that corresponds. Here we are given the capacity. We need the height that is going to correspond to this capacity, which is this volume. So there it's actually a similarity type of a question that we are given. So we have to apply the concept of similar figures, where I told you that you can work with the information that is given in full. So what am I trying to say? Here we are given the height. Here we do not have the height, so we can't use that information. So we are going to use what? The capacity. We have got a capacity of 125 here, a capacity of 1 liter. So capacity is what? It's volume. So I'm saying we are going to take this 125 mils as to 1 liter in this case. Okay, as to 1 liter. So this is volume. So it's going to give us volume factor. Anything that has got to do with the volume, that's your volume factor. So we have to at least find the scale factor. But before we do that, because this is height, and height you are referring to scale factor, remember I told you that scale factor works with height. It can be length, it can be width, it can be perimeter, as long it is nothing to do with square units or cubic units. Okay, so before we do that, we convert to have our scale factor. Let us just work out with these units. These units are not the same, so you can actually write them in the same. That is 1 liter, we know is equivalent to 1000 mils. So this can be reduced, so we can actually obtain our scale factor. Remember, from volume factor, it's a cubed as to b cubed. That is your volume factor. To find the scale factor, you introduce the cube root. That is now the scale factor. So that means we have to find the cube root of this, the cube root of this. If it was area, you find the square root. Okay, so cube root of 125, this is going to give us 5 as to the cube root of 1000, which is going to give us 10. So this is 5 as to 10, of which you can actually reduce by 5. Here is 1, by 5 here it's 2. So it's going to be 1 as to 2. So this ratio that you see is the ratio which is the scale factor, which is the ratio that I am saying it affects sides. As long as sides, we are talking of length, you are talking of perimeter, as long it has to do with centimeters, meters, that is scale factor. Here, capacity, volume, that's volume factor. Okay, so that's what you're going to have in this case. So with this, we have to simplify further so that we can see what we have at the end. So what does it mean? It means according to the scale factor of 1, okay, this one is representing the smaller one. The 125 was the one with the smaller. Remember, it's 125 and 1000. So this one is going to correspond with 20 centimeters of this jug. So it's equivalent to 20 centimeters. What about these two according to our scale factor? What is going to be the height that corresponds with these two? So we can use this ratio because it works when you are dealing with size, length, perimeter, all those. So it means we can be able to find the corresponding height of the bigger jug when it has got a ratio of 2. So as you can see, this is going to be more. So it's 2/1 times 20 centimeters, and this is going to give us something like 40 centimeters. So this is going to be the height now of the bigger jug, or the larger jug. I think all we need, guys, is to revise much on these typical questions on similarity. Yeah, we have to work as much as we can. Okay, anyways, we are given question 5 that there's a trader who made a profit of 16% on cost price by selling a handset for $29. Okay, so take note, there's a profit which means it's an increase. This is the cost price, and calculate the cost price of the handset. So what is going to be the cost price? So actually we just say, okay, before we had this handset sold at what? At $29. This trader actually bought this at a certain price, which we do not know, which is the one that we want to calculate. We do not know the price that he bought it at. But what we know is that at that price that he bought that headset that we are given, the handset that we are given, we know that it was actually at 100%, because that was actually the initial amount that he had to buy this. Now you're into a business where you are selling. Now you want to sell the product that you have. By selling the product, you are going to make a profit, or it is going to be a loss. So a profit that you're going to have, you have to add. A loss means we have to subtract from whatever that we are going to get. That's a loss. So in this case, this trader made a profit of 16%. So we are simply going to add that profit, because it's a profit, so we have to add. So if we add 16% here, it's going to be 116%. This trader made $29. This is this was the selling price. At this percentage, it is being sold at $29, which is just 29, because we are doing calculations. Those zeros, you put them on your final answer, but you're just doing calculations. So our question is, therefore, what was the amount that was there before he had to sell this the headset that he sold for $29? What was that price, which is the cost price? So it's simply whatever that you need, we are given here, which is 100 over 116 times $29, and we are going to obtain the initial price. Sorry, guys. So with this information, we have 100 over 16 times $29, okay, which is less according to this, because we have to find the cost price. So using our calculator, this is paper 2, guys. Use your calculator properly, and this is going to give you 25. So you're going to obtain $25. This is the price that was at 100%, which is the cost price. So which means this $25 is actually representing the cost price. Okay, that is what we had in this case. So actually there are so many ways that we can use. So I want you to try working other ways, compare the answers, and see if we are in the same direction, because here I'm just like bringing some other ways that maybe you were not used to. You were used to this working, and so we are just trying to put it that way. Okay, anyways, on item 2 now, this same trader that we have, we had this handset. Calculate the selling price of the handset if a loss of 13% was realized. Okay, now we know the cost price. Okay, we now know the cost price of what? Of the handset. That the cost price is the one that we calculated before. Remember, we obtained what? $25. So we are now saying the same trader that we are talking about, he made a loss of 13%. This time he made a loss. So what was the selling price after that loss? So we are simply saying this is a loss. Remember, I said when it is a loss, we have to subtract. So remember, this is the cost price, the one that is exactly at what? At 100%. This is the amount that we are given of $25. Then there is a loss that is being realized of 30%. So how are we going to operate this? We just have to subtract, because the loss, remember, loss we subtract. So it's 70 from this 100 minus 30, which is 70%. So what is the amount that is going to correspond at 70%? You do not know. That is your selling price. So how are you going to have this? Simply, this is going to be less. So it's 70 over 100 times $25. So by doing this, we are going to obtain something like 17,5. So 17,5, just write it as you're supposed to write in 2 decimal places, because this is you're representing an amount of mass, so it's supposed to be 2 decimal places. So you see, how do you operate with this? So there are so many ways actually, but this is the easiest because you simply work on percentage. You are not working on much things, so it can be a straightforward way of calculating. Okay, on 5b item 1, we are now asked to solve an equation which is under logarithms. Okay, so this is b item 1. This is an equation, but it is under logarithms. Okay, so this is what we have got for this equation. Solve. So what are we solving for? Definitely we are solving for x, and it's a log. So the best thing that we can actually do for log is to convert or to rewrite this in exponent form or in integral form, where I told you guys that logarithm of a in base b is equal to c can be written in this form: a is equal to b to the exponent of c. Okay, that's a b c, a b c, a b c. So you can actually take it like that. So this is our a here. This is your a. So it's 81 is equal to b to the exponent of c. Your b is x, so it's x to the exponent of 2, like that. So that means we are able to calculate, we can be able to calculate the value of x. How? This is a square. So how do you remove a square? Introduce the square root both sides. So the moment you introduce square root both sides, that means we've got the value of x, which is a plus or minus 9. But knowing that we are dealing with x being a base, so therefore our x can only be a positive 9. So that is what we are having in this case. We do not have a base that is a negative. Okay, our base is supposed to be a positive, like that. I think it's clear. All right, then on item 2, we are asked to simplify, giving your answer in standard form, and we are subtracting there. Okay, so what is the best way to subtract numbers that are in standard form? Remember, if we did together this topic on standard form, I actually indicated that it is best for us to actually convert this to ordinary form than to simplify direct in standard form. Yes, our answer is required in standard form, but it is best for us to do conversions, because we all understand to how to add or how to subtract in ordinary form. That one we are used to. So let us convert this to ordinary form. So the first number is 3 times 10 to the power of 2. So how do we convert this to ordinary form? Remember, we can simply move 3, or this is just 100, guys. 10 to the power of 2, that's 100. So 3 times 100, which is what? Which is 300. Minus, we've got the same thing here. This is 2 times 10 to the power minus 2. So here we can simply move 1 comma to the left, which is 0,2. So this is 0,2 in ordinary form. So it's 300 minus 0,2. So this is paper 2, guys. Subtract with your calculator. You're going to obtain 299,8. But this is not in standard form. This is an ordinary number that you're given. So convert this to standard form. Make sure that the number is in between 1 and 10. So here we have to move 2 commas so that it can be 2,998. It's now in between 1 and 10 times 10 to the power. How many commas did we move? That is 2 commas. The number that we had before, it was 299,8. This is a significant value, we have got a whole number before the comma. So that means the exponent, the power here, is going to remain as a positive like that. We are not going to have anything. It's just going to remain as a positive exponent or as a positive power. Okay, let's see what we have on number 5. We are given to study the pattern. So this type of equation, we have to actually observe what is happening here, what is actually taking place. Okay, so that you'll be able to know everything that is taking place here. Okay, so anyways, that is what we have. So if you are to study this pattern properly, you see that there is something that is occurring, and this is just like direct 0 1 2 3. But here what is happening? 0 3 6 9. It's like because this is just 2 2 2 2 2 2. Everything is going to be 2 2 2 throughout. But here what is happening here? 3 6 9. So it means these are actually multiples of what? Multiples of 3. If you can check 3 times 0, that's 0. 3 times 1, that's 3. 3 times 2, 3 times 3, 3 times 4, something like that. Okay, and here if you are to cross check what is happening, there's a 2 5 8 11. You will see that we have got a difference of 3 here throughout. 3 3 3. Yeah, there's a difference of 3 3 3 3 3 throughout. Okay, so how are we going to simplify this? The first question is to complete the 5th row. This is the 5th row. Okay, so here is just taking as it is, guys. If you cross check, okay, so I can even write here, so it's fine. I can just write here. So it's 0 1 2 3. So this is going to be 4. Okay, here we said these are multiples of 3, so you're simply multiplying 4 times 3, which is 12, and this is just as it is. As you can see, 2 is remaining as it is, and here we are saying there's a difference of what? Of 3 3 3 3 3 throughout. So 11 plus 3, that is 14. Okay, so this is what you're going to have at the end. And the last part is to express x in terms of n. X, this x here, in terms of the row here. So there's a relationship between this number here, like this is your x, like this 2, and the first row. When you are given the first row, the number is 2. On the second row, the number is 5. So this is your n, this is your x, this is your n. So when you are in the third row, the number that corresponds is 8. So what is actually happening here? What is the relationship here? What are we having in terms of x here? If you are to cross-check properly, you'll see that we are simply multiplying by 3 here. 3 times 0 is 0 plus 2, which is 2, okay? 3 times 1, which is 3, plus 2, which is 5. 3 times 2, that is 6, plus 2, which is 8. So 3 is, we are simply multiplying each here, but if we multiply this number here by 3, which is this number here, represents what? Represents n. So we are simply multiplying that number, okay, by 3. Then we add 2. Each time we do this, we obtain a number that is corresponding on these numbers, and these numbers here are the ones that are representing what? X. So that is how you obtain your x. So x is equal to 3n plus 2. So you guys take note, they said study. It's not like something that you're just going to find answers. You have to study that pattern and understand what is taking place. Okay, so here, like I said, let's cross check what I'm trying to say. Let's just take it at this point here. This is the third row, which means our n is what? In the third row, our n is 3. So x is equal to, we must, if we substitute this value, this expression here, we must obtain 8. So this is what I'm trying to say. So let's see. We said this is the third row that we are given, okay? And we are working with this value here, which is in this case third row. So if we multiply this by 2, it is going to be 3 times 2, okay, which is 6 plus 2. 3 times 6 with 3 times 2, which is 6, plus 2, which is going to give us what? Which is going to give us 8. But if you are to cross check in each and every row that you correspond, you are taking these 2. There is second row, this is 1. First row, this is 0. So it means whatever that we are going to get here, we must actually subtract a 1 so that it can give us exactly the third row, which means taking this as 1, as 2, as 3, as 4, as 5, as 6, like this. So we must do adjustments now on our x, because here we are taking x referring to these numbers, but now since there is a 0 here, okay, so what actually happened? What are we going to do from this n that we are having now? Because n is representing 1, is representing 2. That is the case. So that is what you have to ask your question. So the difference between these two is the 1, is the 1. So which means at the end we are going to subtract. So therefore our x, we are going to subtract 1. So it is going to be like this, 3n minus 1. Okay, that is going to be the actual expression for x. So that means here, if you are to take any value, like you can take 5, you can take 4, you can take any value of your choice here. Like this is 5, okay? So I can just substitute n is equal to 5. N is equal to 5 here. 3 times 5 is 15. 15 minus 1, it's 14. I am obtaining 14. N is equal to 4. 3 times 4 is 12. Okay? 12 minus 1 is 11. N is equal to 3. 3 times 3, that is 9. 9 minus 1 is 8. So as you can see, they correspond nicely. So that is what we're going to have. So expressions, guys, this is how you simply create them. But as we are going to revise as much as we can, you will see that it is going to be easier for us to create these expressions. Yes, because actually from the question that we had, this was my first question to explain to you. So it can be, look, it can be like as if there's so many things that are actually taking place, but it's actually nothing. As you are going to see, as we are going to revise other questions, you are going to understand that this is actually nothing there. We'll see as we will be revising questions together. Number 6, we are now given a question which is under construction, which is use a ruler and pencil, ruler, compass, all those only for all the constructions, and clearly show. And this is actually written in bold to make sure that everything that you do, guys, is supposed to be accurate. Okay, all constructions should be on a single diagram. So we are given to construct in a single diagram triangle ABX. So this is a triangle. Line BX is already drawn. Okay, so this is our BX. So now, because this BX that we have is not given the dimension, we have the dimension. Okay, BX, the dimensions are there, 7,5. So that means I'm going to redraw, because some of these diagrams, what they do, what appears, what I've seen is that they won't be as accurate as they are supposed to be. So I don't know with this one if it is accurate. If it is not, therefore we have to redraw this line, guys. That is what it means. We must be able to redraw. So this one is 7,5. So I just want to cross check if it is actually 7,5, because it must be equal to this length here. Okay, guys, instead of us redrawing, let us just use it like that, because we can waste much time. Let us just use it like that. Okay, so this is our BX that we are given. So all we need here is a sketch. Okay, because already we are given like this. This is our X here, this is our B. So that is your sketch here. So this is your X, this is your B. Okay, then you are given that it's a triangle AXB. So definitely this is your A. And we are given angle AXB is 60 degrees. AXB, this one is what? at 60 degrees. Okay, so that is what you're given. So this is the sketch, guys. We can simply have our sketch and draw. And also a x here, a to x is 5 centimeters. So once you have a sketch, it's going to be easier. You know how to construct this. So all we need is an angle of 60 degrees at what? At x. And all these, guys, you know how to construct these angles. I told you from scratch how you are able to construct this angle of 60. Remember, you have to mark at point x. All right, this is our point x here. So since our 60 is supposed to be inside the triangle, it's supposed to be on this side here. This is where you're supposed to create your 60 degrees. You create it on the side that is supposed to be inside the triangle. Okay, so that's our part of this same circle. Then we mark here where this point, okay, where this arc meets the line, that is at this point. Mark it properly. Then you mark back on the line, on this arc, sorry. So marking back to the arc, as you can see, these two, they actually intersect at that point. So what you're going to do is to join. Okay, so we are going to join this to x. Already point x is given, so all you need to do is to join. And this is not like drawing. All this is constructed. So this line is supposed to be an extended line. Okay, do not just join this point direct to x. No, that one is drawing. Here we are constructing. Okay, so this is our x to b here, and we have got x to a with an angle of what? Of 60 degrees. So this one is exactly 7,5. So we know that from this x into this angle of 60 degrees, reaching the point A, it is supposed to be this length that we are given, which is 5 centimeters. So all we need is to measure 5 centimeters and mark. So remember, everything we are told to use ruler and compasses. So you have to measure 5 centimeters. Okay, so on your compass there, measure 5 centimeter. Okay, sorry, something like this. So that's my 5 centimeter there. So all you need is to measure properly. Okay, so with this part, with your compass, because everything is supposed to be done with the compass, I have to mark now. Okay, on this line, this is my 5 centimeters, and this is the point what? The point A, which is 5 centimeters from what? From x. So by having this, I can join now. Don't leave this. Join this point A and B together. Okay, so you're going to join these 2 points, A and B. All right, so that is construction. So we have constructed the triangle AXB, just like that. Is 3 marks, guys. You see that construction is just taking marks, or just taking marks. This one. Construct the locus of points which are equidistant. Take note, equidistant from XA and XB. So take note, XA is a line, XB is a line, and I told you that whenever 2 lines meet, you have to bisect the angle, that is the part that is repeating here, XA, XB. So you bisect this angle that is repeating, this one, angle X. Okay, so it's X to A, X to B. So X is repeating, so you have to bisect this angle at X. So how do I bisect an angle? Guys, I don't know what is happening with this thing. Okay, sorry for that. So how do I bisect an angle? That is the question now. So remember, to bisect an angle, we have to mark at this point here. So I'm going to mark at this point. Just mark arcs on these lines that we are talking of, XA and XB. Okay, so just mark an arc here, another arc here. All right, just like that. So you have to mark arcs. Okay, so without changing this length that you have on your compass here, don't change it. Mark again 2 arcs from this inside the triangle, or just in between the angle that you want to bisect. So you just mark an arc like this. Then with this same distance again, we mark an arc here. Sorry guys, this is now because of I'm holding with the other hand. Yeah, okay, something like that. Okay, so where these 2 meet, join back to the point what? To the point X, just like that. So by joining to the point X, we have managed to bisect the angle of 60 degrees, that is dividing this angle here into two equal parts, that is to bisect. So bisect, don't indicate that this is going to be 30, this is going to be 30. Just bisect the line, leave it like that. Okay, so you go on to the other part. We need the locus of points which are 3,5 centimeters from X. So what is X? X is a point. Locus of points equidistant from a fixed point. Remember that one. It's a what? It's a circle. So you're going to construct a circle of radius 3,5 from point X. That is at point X here. So we have to measure 3,5. Okay. So that's 3,5 somewhere here. Okay, so with that distance of 3,5, you draw a circle. Okay, so this is my 3,5. With this distance, I'm going to mark at point X here. Okay, at this point now, let us mark 3,5 and we draw a circle here. So this is 3,5. Okay, this is 3,5 from this. So now we've got something of this nature. All right, something of this nature. So this is our circle, locus of points equidistant from a fixed point, a point that is fixed. That is what we have there. If a point is fixed, it's a circle that you're going. So it's actually a definition of a circle, locus of points equidistant from a fixed point. Okay, so that's actually what you had. And show by shading now the region R inside the triangle such that R is closer to XA than XB and XR is less than or equal to 3,5 centimeters. Okay, so let's start by this, that R is closer to XA than XB. Okay, this is our X to A, this is our X to B. So we had an angle bisector. Remember that we had here. We had an angle bisector. This is supposed to be not a, this region is in the triangle. Okay. That's the first thing. It's inside the triangle and closer to XA. This is your XA, this is your XB. So closer, which means this is the line that is going to divide the two to give us a region which is closer to XA than to XB. So we are talking of this region here, this side. So what does this mean? If we are referring to this, we are now left with two regions. If you have to cross check, there is this region and this region, because these are the two regions which are on this side. That is where now we have got this last statement which is saying XR is less than or equal to 3,5. Okay, the region that we are talking about, it is less than or it is equal to 3,5. So what is going to give us this 3,5? Remember, we drew this circle here, which was 3,5 in radius. From this point to this point is 3,5. From this point to this point, that is the radius of the circle. From this point to this point is 3,5. So they are saying this region is less than 3,5. So between these two regions, which one is less than or it is equal to 3,5? Definitely we are referring to this region that is below the radius, because this one is out of the circle, is greater than 3,5. So this is actually out. So our answer is going to be here inside the what? Inside the triangle. So this is going to be the region up to where this circle is. Okay, bounded by this line. Remember, this line is also playing a what? A role, because we are told that this region is nearer XA than XB. So we are talking of this region closer to this, and the region is less than or it is equal to 3,5. So that is where your R is going to be located. Anywhere into this region, anywhere here, that is where your R is. Okay, so that was actually the consideration. Now the question is measure and write down the length of AB. So AB now is because of this length that I had here, which was affecting, but all you need is to just use you can even use your divider, you can use your ruler, guys, just to measure properly. This is something like what, 7, oh, Yeah, something like 7. I don't know what is your view there. 6,9. Yeah, 6,9 or 7. Say 7 there. Okay, so that is what you're going to have. So this one, you write it here, 6,9 centimeters. So everything was done on the diagram like this. You don't write this on the diagram, you write it where it's supposed to be written. Okay, so I think everything that we had there, construction, guys, as you can see, is one of the easiest part that you can actually utilize or capitalize on. That it can be an advantage actually. Okay, let's see on number 7 what you're given. We are now having an information that is in the diagram is a ABCD is a cyclic quadrilateral in which AB is 1 centimeter. So AB, that is the length here from A to B, it's 1 centimeter. Okay, calculate AC. So this is actually a triangle. As you can see, it's a non-right angle triangle. So let me just put it this way. Here, if you are to cross check, yes, it's something that has to do with a circle, but this is just a normal triangle that they just want us to capitalize or to use. Okay, this is your A, this is your B, this is your C, this is 1 here, this is 4, and this is 115. You're just taking this information here, your A, B, and your C, this part. Okay, so how can I calculate AC? It's just a normal triangle, so which means I can apply cosine rule. Remember, cosine rule states that if you are given two sides like this, okay, I've got two sides and an angle that is in between, then A squared is equivalent to B squared plus C squared minus 2BC cos A. So actually, yes, if this is B, yes, we can write it in terms of B because it's actually A, B, and C. So someone might, why can't we just write in terms of B, because this is B that we have? Okay, let us do that. Let us write it in terms of B. So which means in terms of B, this is your B here, this is your A, and this is your C. So this B squared is equal to A squared plus C squared minus 2AC cos what? Cos B, which is actually just one and the same thing, guys. Okay, so what are we going to do? We have to substitute now. This is our B squared, which is AC squared, the side that is opposite to that, to the given angle that we have got here. So that means that our AC squared is going to be equal to the A and the C. These are the sides here, A and C. That's A and C, that's 4 and 1. So it's going to be 4 squared plus 1 squared minus 2AC, which means it's going to be 2 times this 4 times this 1. Okay, cos of the angle, that is cos of this angle here, which is in between the given sides, which is 115 degrees. So that's what you're going to have, guys. So AC squared, that's 4 squared, which is 16, plus 1 minus 2 times 4 times 2 times 1, which is 8. 2 times 4 is 8. 8 times 1 remains as 8, isn't it? Yeah, that's going to be like that. So this is what you're going to have at the end. And cross-checking or simplifying further, that's 16 plus 1, which is going to be 17 minus 8 cos of 115. And remember, guys, okay, sorry for that, this thing is, I don't know what is happening. It's just because of this weather. I think now it's affecting, even there's too much moisture, it's very, very cold. Okay, so this is our AC squared here that we have got him. So what am I going to do? At least simplify cos 115. This 17 minus 8 by cos 115, which is something like negative 0,4, not 8, but 0,4226, something like that. So this is just an indication that you have for cos 100 what? Cos 115. But all we are going to do is you refer back to this stage here. I want you to use your calculator at that stage. Just use your calculator to evaluate that as it is. Okay, so if you simplify this from your calculator, you are going to obtain something like 20,380,946, yeah, something like that. So that's what you're going to have. And this is AC squared, and all we need is to find AC. So we have to introduce what? The square root both sides to remove this square. So AC is going to be the square root of 20, which is 4,514 5 to 6, something like that. Okay, so this is our AC, which is 4,51. Okay, to remember most of your accuracies to 3 significant figures. I don't know, we just cross check with information that you'll be given. So that is what you're going to have in this case. These are centimeters actually. Okay, centimeters. So that is what you're going to have, and using this value. So in this case, just for the case of the values that you're going to have, you just have to use this value as it was, but that is your AC in this case. Okay, so I think we can have the other question. Let's see the other question. Calculate DAC. Okay, that is item 2 now, to calculate DAC. Okay, so DAC, this is our DAC. Okay, so remember we have got this here, this length AC. Okay, this one is now there, and also using your idea of cyclic quadrilateral, because this is a circle, so you know that if this is 115 opposite angles of a cyclic quad, actually they give us 180, so you can obtain this angle here, 180 degrees minus 115, which is going to give us 65 degrees. So this is 65 degrees here, and we have got this AC. Remember we calculated this, so our diagram is going to be just like this. Okay, this is 65 degrees, which is at D. Okay, at this point I just took this A, D and C. Okay, like this. Okay, so this is my AC, the one that I calculated. Remember we obtained this was 5,41. Okay, something like that, 5,41. Okay, this is what we had. So this is the angle that we have, and this side we are given. Okay, we have got this side DC. We have got DC, which is what, which is 3, and the question is to calculate the angle DAC. Okay, that is DAC, this angle here. So what are we going to use? Which part are we going to use? So definitely this is what, sine rule. We can apply sine rule in this case. Why? If you are to cross check, we want to calculate an angle which corresponds with a side. Okay, here we are given an angle which is already corresponding with a side, so which means we can apply sine rule, and sine rule states that sine A over A is equal to sine B over B. So it's sine, the angle that you want to calculate here, let's just say sine A, let's just put it as sine A. Okay, over this side 3 is equal to sine the angle, this one that you are given, sine 65 degrees. Okay, over the corresponding side, which is 4,51. You just use that value as you had. So now it's because here I just used the whole value as it was. I don't know what happened, but let's just see, multiply by 3 both sides, multiply by 3 both sides. So you're gonna cancel this, so this will be sine A is equal to, if you simplify this, is going to be 3 sine 65 degrees over 4,51. Okay, so you can simplify this, find the decimal part of sine A, which is going to be something like 0,6, something like that. So all you need, guys, is to make sure that you are using the actual values there. So that is going to be sine A, but all you need is to find the value of A. So remember, how do you find the value of A? A is going to be what? Sine. So this is sine, which is from your calculator is shift sine or second function sine. I don't know, depending with your calculator. So for me it's second function shift. Okay, I don't know, according to your calculator, guys, you just see. So, and also you're supposed to use this value as it is. So I'm just writing the part, but you're supposed to write everything as it is. Okay, so this is going to be 37,03, something like that. So which is something like 37,0 degrees. If you round off, it's going to be 37,0. So which means that's our angle DAC, which is 37,0 degrees. Remember, your angles are supposed to be given what to one decimal place, so you have to write that ,0, that one, because your angle is given to one decimal place at the end. Okay, so this is how you just play around, guys. These are just like play around questions. Just want to test you. Do you know how the relationship of this? Okay, 3 people can complete a certain task in 6 days. Okay, these are 3 people. They are completing a task in 6 days. Okay, calculate the number of people working at the same rate who can complete the job in 9 days. Okay, if 3 people can complete in 3 days, guys, what more about 9 people? How many? So what does it tell us here? Does it tell us that it's going to be done by more people? No, because the days are now many, so it's a reverse of what we know. This is done by less people, because 3 they took 6 days. What about those who can take 9 days, guys? By just looking at this, these people must be less than, because they took more days. Okay, so it's going to be 6/9 times 3. Okay, so by use your calculator effect as you can observe 2, so which means we are referring to 2 people here. These are the ones who can take 9 days if 3 people can take 6 days working on the same rate. That is what we had. So these are some of the typical questions, guys, that you can just have. As you can see, that was number 7, and it will be like you were working with this topic here, psychogeometry, of which is just an ordinary question that you're given. Okay, anyways, we are given that there is Mr. Moyo here who wants to plant mango tree and guava trees in his plot. He wants at least 4 mango trees and at least 2 guava trees. Let X be the number of mango trees and Y be the number of guava trees. Okay, so let's just put this this way. This is number 8. So X is indicating, or X is representing what? X, the number of what? Of mango tree here. So that's your X. Okay, then our Y is representing what? The guava tree. Okay, that is what you're given here. So form 2 inequalities. From this information, they are saying there are 2 inequalities which has been given that we need to formulate. And which are these? Okay, let's start here. He wants at least 4 mango trees. At least. Remember, guys, I told you that whenever you see at least, it means what? Greater than or equal to. So X is the one that is representing what? So X is greater than or equal to 4. Okay, and at least 2 guava tree, and guava is represented by Y, so Y is greater than or equal to 2. If it is at most it's less than. Okay, so this is at least. Okay, that's greater or equal to. If it is at most, this one is going to be less than or equal to. Okay, so then would be there is enough space in his plot for not more than 9 trees, which means not more than, which means they can be up to 9 or they can be less than 9. The number of trees to be planted. And which trees are we talking about? We are talking about X mango trees and Y guava trees combined. So which means the inequality that is going to be formed on this item, it is going to be X mango trees plus Y mango trees. All together, they must be less than or equal to 9, because there is no more than, the space is not for, it is for either 9 or less than 9. So it is going to be less than or equal to 9. So that was the inequality there. Okay, let's see another part. We are now told that mango trees cost $14 each, guava tree $24. Okay, Mr. Moyo has $128 for the purchase of trees. He wants now to buy the trees that you want to plant. So they are saying each mango tree is costing $14. So what does it mean? It means each, if we multiply each is X, so we are going to have 14 times X plus how many that we have for the guava is $24. So it's 24 times Y. Everything is going to be under this amount of $168. This is the whole amount that Mr. Moyo has. So it means we are going to use the amount up to $168 or less than $168. So that means our inequality is supposed to be less than or equal to, because this is the amount that it's like you want to buy something and you only have $5. How do you expect to take something that is costing $6? It's impossible, because you have to buy with what is directly in your pocket, either less than that or directly what is in that in your pocket. So now we can reduce, guys. We can just choose which is just divided by 2, isn't it? Yeah, let's try to reduce by 2 here. 7x by 2 here, which is 12y, is less than or equal to by 2 here, which is 84. So that is the inequality now that you're given at the end, that they asked now to reduce this until it gives us this. Okay, so these were the inequalities, guys, that we formulated, and as you can see, it's just 5 marks for formulating inequalities. Then now they're asking you to draw these inequalities on the grid that you're given on page 22, and this is page 22, the one that we have actually messed up. We have actually messed this page up. Okay, anyways, let's just put it this way. I'm just going to check this part here. All right, so this is our page 22 here. Okay, so we are going to represent those inequalities that we wrote down, and these are the inequalities. Okay, so let's start with the first one. Already this is x here. We're given mango trees, y guava trees, so it's direct. Okay, so the first inequality is x is greater than or equal to 4. So all you need is to draw the line of x is equal to 4, and it's a continuous line. We've got this equal to this bar here. It means it's going to be a continuous line. Okay, so that's what you're going to have, not broken but continuous. So you're going to draw the line of y, x is equal to 4. So x is equal to 4 is directly at this point here. This is where x is equal to 4, at this point. So as we need the line at this point, so it is going to be, definitely it's going to be a vertical line. Okay, so this is going to be a vertical line at x is equal, so you just draw directly at x is equal to 4 there. Okay, so it is going to be like this. Okay, sorry for that. So that is our x is equal to what? X is equal to 4, this one. So on this line, you write down the equation here, not the inequality. X is equal to 4. This is what you write, the equation. The inequality now follows after that, where now you have to indicate by shading, and you are not only shading, and you are shading the region that is unwanted. Okay, because we need the part that satisfies, so we are going to shade that region that is what? Unwanted. Okay, this is unwanted region. So which means when we are referring to the unwanted region, we are saying that here x is greater than 4. So which values are we talking about which are greater than 4? We are talking about these values here. These are the values which are greater than 4. From this 4 was is greater than or equal to, from 4, 5, 6, when these are the values. So which means the ones that we do not need are these ones. This is your unwanted. We do not need these values here. So these are the ones that we are going to shade. So all you just need is to indicate this. Okay, so this is our unwanted region, this one. Okay, shade that region just like that. You move on to the other one. Y is greater than or equal to 2. So all you need is to draw the line of y is equal to 2, and it's a continuous line. We still have the bar there, greater than or equal to. So this is at y here. Y is equal to 2 at this point. So we have to draw a line here, continuous line, remember, of the inequality. So the inequality sign tells us the line how it's supposed to be. Okay, so this is the line of y, right? The equation of the line. Okay, the inequality part is where now we shade. According to this, our values of y, they are greater than 2. So here we are referring to these values here, greater than or equal to 2, 4, 6, 8. These are the values of y that we are talking of. So this is the false region. So you shed that false region or the unwanted region, just like that. So this is the region that we do not need, that is not needed here. All right, so I think we are together. Let's move on to another part. X plus y is less than or equal to 9. Okay, so this one is still a continuous line again, but how are you going to have this? This one you can easily use double intercept, remember guys, or you can use any method of drawing a straight line, table values, I don't know which one, but it's best for us to just apply double intercept. Remember I explained that double intercept, all you need are the values of x and y here, 2 points. When x is equal to 0, you find the value of y. When y is equal to 0, you find the value of x, just like that. So when x is equal to 0 here, when x is equal to 0, it means y is equal to what? Y is equal to 9. When y is equal to 0 here, it means x is equal to what? X is equal to 9. So that's your double intercept. So you're going to mark point 0.9. That is 0 here, 9. So 0.9 is in between 8 and 10. So it's 1, 2, 3, 4, 5. Okay, so that's our 0.9 here. And 90 here, 90. So 90, that's somewhere here. We count here 90, 1, 2, 3, 4, 5. Okay, that's our 90 here. We mark the point. So all you need is to join this point 9 here and also 9 here in x. All right, so make sure you join properly these two like this. All right, so that is how it's going to look like. So this is the equation. Just write the equation: x plus y is equal to 9. Okay, so which part are we going to shed in this case? Okay, here we need a region that is less than. X plus y is less than. This is a lesser region. So if you are to compare these two regions, this is a lesser region to y, this one. This is the bigger region. So we are going to shed the bigger region, this one. This one, comparing values, we are saying according to this line, these values here, they are lesser than. This one, they are bigger than. Okay, so you shed the ones which are bigger than. This is the unwanted region. So you can easily shed this that way. Okay, this is your bigger region, like just like that. Okay, then the other part, or the other inequality, 7x plus 12y is equal to 84. So this one we also can apply our double intercept. I don't know if it is going to be clear. Yeah, we can actually apply because x is there. So in this case, using our double intercept, we have to try if it is going to work. Okay, so when x is equal to 0 here, when y is equal to 0, remember that's the concept xy, xy. Okay, when x is equal to 0 here, that's x is equal to 0, 12, y is equal to 84. So you divide by 12 by 12. That means y is going to be 7. Okay, when y is equal to 0, we close this part. So 7x is equal to 84. So if 7x is equal to 84, divide by 7 by 7. X is going to be 12. Okay, so these are the points that we need: 0, 7 and 12, 0. Okay, that's 0, 7, 0 here, 7, it's in between 6 and 8. So 1, 2, 3, 4, 5, that's somewhere like here. That's our 0, 7 here, and 12, 0 is here. Okay, so this one I'm just going to join with this part so that it can be, I want it to be at least clear. So I'm just going to use this one. So you join here at 7 and at 12. That's double intercept method. Okay, simply double intercept method. So let's see. Okay, so as you can see, it's simply taking a little piece here that was being taken here, a little small piece that was taken. Okay, so anyways, we are going to write the equation of the line. Remember, this is 7x plus 12y, which is equal to 84. You write the equation, not the inequality. Guys, look at this. This thing is affecting, and if I'm not looking at the screen, it's going to affect me a lot. Okay, anyways, that's how it's going to look like. So here we said it's at 7 and at 12. So there is too much moisture, so this thing is it's sensing that moisture. I don't know. So that is how it's going to look like, but at the end. Okay, so now where are we going to shed? Okay, so if you are to cross check, this one is still the same way that we are talking about the lesser region. Okay, and this is the lesser region that we have here. This is the lesser region. So the bigger region is this one. That is, I think, guys, make sure that you watch those videos. I'm going to work on separate videos again. Maybe it can be clear, but here we're going to shed the bigger region. This one, this is our bigger region on this line. Okay, so which means actually this part has been shaded, and the only region that is going to remain in this case, if you are to cross check properly, there is only this part here that is going to remain here. This is the region where everything is going to be taken from, or where our answers is going to be taken. Here I'm just going to write R, but it's not like we are told to represent that. I'm just going to represent, but this is the region that you're talking about. This one, this is our region. Okay, so I think from this it was a little bit clear, and let's see another part of the question. So this was actually just to indicate, okay, I think everything is there on the grid. Yeah, everything is just like that. So that's what we had, guys. All the inequalities, they are being presented, so it can be just like that. Okay, so I hope everything is there. Okay, then now indicate by shading, then use the graph to find the number of trees that will use the greatest amount of money. So which one is going to give us the greatest amount of money? Okay, so the greatest amount of money, all you need is to check from what, from this region, that is the one that is going to be like from the points that we have. So it's a trial and error type of equation, but you are not just trying, you are trying working with the points that are inside the region here, like this one. These are the points. Okay, let me choose another. These are the points that you just choose for visible points. Like this one, it was what, 7, this was 7 2, isn't it? 7 2, 1 2 3 4 5. Yeah, like this point here, 7 2. Okay, we move on to this one, which is here, which is 4 2. Okay, then here it's 4. This one is no longer take because it's 1 2 3, it's a decimal, so you have to take this one, 4 4, this one, and 6, that's 1 2 3 4 5. This is part is 5 here, and this point here can be taken. Okay, so these are the 4 points that we can actually try. This one, there's nothing here. 4 5, yes, we can try 5, but 5 here is not corresponding with anything, unless maybe because of I was using a marker, so this one took another space, but it's 1 2 3 4 5. Okay, it's because I was using the marker here. This point is supposed to be there. So these are the points. So this one, which means we can't try this one, we have to exclude this one. You try this one, we try this one, we try this one, we try this one, to substitute and see the one that is going to give us the highest amount. So I want you to work on that one. You give me the answers there. So I'm referring to points such as 7 2. Okay, this one, 0.42. So these are the points which are inside what, the region, and they are also on the region, because this one is a continuous, they are continuous lines. Okay, so this one is 4 4 4 4. So these are combinations. This one I'm listing combinations. Okay, 5 4, this one is 5 4. Yeah, verify this point, guys, verify this point. Okay, so like I said, yeah, this can be, this one is in between, so we can't take this one, we just take this one. So from these 4 combinations, we are simply having the value of x and the value of y, the value of x, the value of y, the value of x, the value of y, something like that. Okay, so all you need is to substitute on that expression that used the money. Do we still have that? Yes, we have it here. Remember, we formulated an expression here that had to use the amount of money that he had here, and we reduced it up to this. So all you are going to do is to substitute and see which one is going to give us the bigger value. When you substitute the value of x and the value of y, what I'm trying to say is that you can just take this 0.72, x is 7. Okay, so our expression is like this. We reduced this expression to 7x plus 12y is less than or equal to 84. So here x is 7, so you substitute here when x is 7, when y is 2. Okay, you go to this one, do this one, try until you find the exact one. So yes, because everything, but you have to try. So I want an answer from you guys. Tell me which one is the exact values. Just use your calculator. Everything is direct, just like that. Everything is direct, guys. Okay, anyways, on number 9 we are given that is a survey which was actually carried out to find the ages of 60 patients at a hospital. We are given the table, and these are 60 patients. Find the value of m. So as you can see, guys, these are frequencies. So to find the value of m, we simply have to add everything and subtract from what? From 60. Okay, so if we add everything, we're going to obtain 52, and this is going to be 1a 60 minus 52, which is what? Which is 8. So that's your m here. So m is 8. Okay, then find the value of n. So the value of n, these are cumulative frequency. So cumulative frequency, remember, we are adding frequency. Here we started with this 0 here, that's 0. So it's 0 plus 4, that's 0 plus 4 here, which is 4. So it's 4 plus m, and our m here is 8. So 4 plus 8, which is what? Which is 12. So our n is 12. Just like this, we are at 12 now. So 12 plus 11, which is 23. 23 plus 15, 30, something like that, until the last value. Okay, then that's what we had. Find the probability that 2 patients chosen at random will both be less than or equal to 45 years in age. Okay, we are talking about 2 patients drawn from the same region, because this region, we are talking about a region where they are less than or equal to 45. And here we are told that those people who are less than or equal to 45, there are 48 of them in number. So it is going to be 48 over the total, remember, probability, the required outcome over the possible outcome. So the possible outcome are the number of students, which are the patients, or these are patients. Okay, multiply by 50. This is 48. So we took 2 from the same group. So the second one is going to be 47, because they were 48. So now we are left with 47, and the total is now affected. We have taken 1 patient, is no longer there. So that is what you're going to have. And if you simplify this, you're going to obtain 188 over 295. Okay, so this is how we work out probabilities, guys. Okay, then we are now given on the other part now to draw the cumulative frequency curve. Okay, so let's just see, guys. I have this aside here, so yeah, let's just put it this way so that we can have our cumulative frequency here. So in order for you to have the cumulative frequency, you work with the cumulative frequency, this one, not this table here, the frequency one. Okay, this one, not this one. You use the cumulative frequency. This is an OGAF. So you just, and how do you mark this? Remember, I told you guys, you use upper classes. Okay, you're going to work with upper classes versus the cumulative frequency. So these are the upper classes, this one 10, 20, these are the upper class 10, 20, 30. Okay, so you mark like points, 10 versus 0. Okay, that's 10 here. This is your edge. Okay, so this is 10 here versus 0. So you mark as a point. Okay, you move on to 20 versus 4. So this is 20 versus 4. So here it's just counting the number of boxes as they are. I think it's just direct calculation, because the whole of the box is representing what? This is representing 10. So which means each box is 1. So it's 20 versus 4. It's 1, 2, 1, 2. Just count 4 boxes. 1, 2, 3, 4. Somewhere here. Okay, so it's because this box that 2, 2. Okay, so that is where you're going to. So just count 4 boxes. 20 versus 4. Okay, then you move on to this one. Is 30 versus 12. So this is 30 versus 12. This is 10. Count 2 boxes. 1, 2. This is 12 here. Okay, the other one is 35 versus 23. 35 is in between 30 and what? 40. So, and 23. So it's 1, 2, 3, 4, 5. This is 35. at 20, 21, 22, 23. Okay, so this is 35, 23, 40, 38. This is 40, 38. This is 40 versus 40 here. So 38, 39, 38. These are two boxes below it, below the 40. Okay, that's your 38 here. Okay, then it's guys, sorry, this is 40. Okay, exactly 40 and 38. Then 45 and 48. Okay, 45 in between here and 48. That's 45 and 48. So let's just say this is a 50 here. It's 1, 2, 3, 4, 5. This is our 45 at 50, 49, 48. So it's somewhere here, just two boxes below 50. Okay, that will be your 40. So you just mark properly, guys. You can do this in a much better way. 50 versus 53. So this is our 50 here. Okay, versus 53. This is 50. 1, 2, 3. So that's 53 there. So it's 50 versus 53. And the last one is 60 versus 60. Okay, that's 60 here and 60 there. 60 versus 60, 60, 60. All right, so these are the points that we had. So we have to join properly and at least have our ogive in this case. So it's called an ogive or a cumulative frequency curve. Okay, so at this point I'm just going to shift my graph this way so that at least I can produce a nice curve. So from 10 versus 0 here to this point. Oh, sorry for that. Here, guys. All right, something like this. All right, so here we have 2. We join like that. So I think we can even draw a much better curve, guys, than the one that I'm having here. We can actually have something smoother and not glossy. Okay, so this is how it is going to look like at the end. We just have this graph, and starting at 0, that is how it is going to look like. So that's a cumulative frequency curve. Okay, a cumulative frequency curve, which is an ogive. You draw it using upper classes, and you'll be having the edges here. Okay, the cumulative frequency, which is the upper class, and the cumulative frequency, just like that. So that's what we had from this particular question. So as you can see, guys, these are how they can ask this question, just to draw the graph and so forth. So you have to be very, very careful how you attempt each and every question that you'll be given there. Okay, then let's see on number 10, this part that we had, which is actually mensuration of solid shapes. So these are solid shapes, and actually solid shapes, guys, I actually prefer you to revise much on them and so forth if it is that you want to answer solid shapes. That is, if you want to answer solid shapes, because you're not going to have a direct question or something that is direct. Each and everything you have to apply. Okay, so here we are given now a cylindrical wood PQ OP, that is OPQR, which was, now it was cut. As you can see, it's open. We're asked to calculate the area of the cross section OPQR, that is OPQR. This is the cross section, which is what which is a sector. This one is actually like a sector. As you can see, it's now a sector. So all you need is to find the area of a sector, and this is OPQ, which means this one, the bigger part. So that means here we have to use this angle that is inside the sector, this one. So we know that angles at a point they add up to 360, so we're going to subtract this from 360. That's 240 here. So this is 240 degrees. Okay, so the area of a sector, we know that we can take that from the area of a circle. Okay, we can take that from the area of a circle, since we know that area of a circle is pi r squared. So area of a sector is theta over 360 times pi r squared. Okay, so our theta now is the 240. So it's 240 degrees over 360 times pi, which is 22 over 7 times r squared, which is in this case the radius is this 10 from O to P is 10. or 2r is also 10. So that's 10 squared, of which you can just use your calculator at once. And this is going to give us 209,5238, something like that. Okay, so that's what you're going to have as your area, which is 209,5. Okay, so all you just need is to use your values properly. So here I actually, let me just use this as 4. Okay, if you round off. Okay, so but the degree of accuracy, guys, but here I'm just you doing this for calculation's sake. Okay, then calculate the volume of the block. So whenever you're given such a block, what you need to know is that volume, guys, simply means the cross section. Okay, that is your cross sectional area times the height. That is what you refer as volume. So in this case, what are we supposed to have for this particular section? This is the height from this. If you can cross check, this cross section here that you see here is the same cross section that we see here, and they've got same area. So that is the area of the cross section. So it's the area of this cross times the height separated. It is separated by what? By 15 centimeters high. So that is what I am saying here. Okay, so that's your cross sectional area, which is this one that you obtained, 209,534, something like that, the whole part that you obtained. Then you multiply by 15, which is the height, just like that. So we are going to have something like 3142,857, something like that. Okay, which is going to be 9. This is cubic centimeters. Remember, this is volume, so just round off depending on the degree of accuracy that you're given, but that is what you have there. Okay, calculate the calculate the curved surface area of the block. Okay, I'm just minding this thing that we are working with. Okay, so anyways, the curved part, the curved surface area, that is the curved part. Remember, the curved part of a cylinder is given by this formula 2 pi RH. Okay, that is the curved part is supposed to be 2 pi RH, but here because of the angle that we are given here of because it's like we're having the angle of the sector, so the curved part is going to be affected also by the what? By the angle. So it is going to be theta over 360. So the curved surface area, okay, is going to be, this was supposed to be the formula, but because of the angle that we are given, now this is going to be given like this. The curved surface area is going to be theta over 360, which is 240 degrees over 360 degrees times 2 pi RH, which is 2 times pi 22 over 7 times the radius. Our radius is 10 times the height. Remember our height, guys, our height is what? Is 15. Yeah, so we're going to multiply by 15, and this is going to give us something like 628,57, something like that, which is going to be 6 square centimeters. So this is just area. Okay, so I think it was just a direct question, guys, this one. Then we are given on number B that there's a Zimbabwean motorist travels to Botswana on a holiday. The motorist travels a total distance of 3,600 kilometers in Botswana. The motorist car consumes petrol at a rate of 9 kilometers per liter of petrol. Calculate the amount of petrol used in Botswana. Okay, so it's just like a simple proportion, guys. Per each whenever there is 9 kilometers, we are going to use a liter, but we traveled how many kilometers? 3,600 kilometers. So how many liters is it going to be? Just like that, simple proportion, isn't it? So this is going to be more. So this over this times a liter is going to give us the exact answer. So we've got 3,600 over 9. So this is kilometer times 1 liter. So this will cancel, and we are going to obtain 400 liters. So that is the amount of petrol that was used in Botswana, that is 400 liters. Okay, so that's what we had from this particular section. Now they are given that Petrol cost 6.5 pula per liter in Botswana. Calculate the total cost of petrol used in US dollars if the exchange rate was $1 to 8 pula. Okay, so let's start by knowing the total amount that was used to buy the petrol. Remember, we used 400 liters of petrol. This is what we used, okay? And we are given that it's 6.5 pounds per liter. So how much are we going to have in pounds if we are given 6.5 pullers? So guys, okay, it's fine. So this is actually 6.5 puller per what? Per liter. Okay, this is just a liter. What about 400 liters? What is it going to give us in terms of the puller there? Okay, so it's just 400 over 1 times 6.5 puller, and this is going to give us 2,600. So 2,600 puller. Okay, so the amount that was used was 2,600 puller, but this amount is not needed it's needed in US dollars. We are given that per each US dollar that we have, it is corresponding to 2,000. Is it 2,000? It's 8 puller. It is corresponding to 8 puller in this case. So what about 2,600 puller? How much is it going to give us in US dollars? This thing has started again, guys. Okay, how much is it going to correspond in what? In US dollars. So this is the question. So it's just a simple proportion, US dollar 8. So this something like that. Okay, so what are you going to have? So it's gonna be more, definitely. That is 2,600 over 8 multiplied by $1. So I have to like be recording, looking at the screen, like, guys, this is hard. Okay, anyways, if we are to divide properly, this is going to give us 325 US dollars. All right, that's 325 US dollars. So that is what you're going to have in this case. So it's a matter of working or understanding the concept that you'll be given. Okay, so that is how you simply work out these typical questions. And they were given on number C that given that f of x is equal to 4 minus x squared, find f of minus 1. So this is a bonus question, isn't it, guys? This is just a bonus question that you are given there. Simply substituting the value of x, f of minus 1, simply where x is minus 1, where there was x, substitute minus 1. So f of minus 1, in place of x, substitute minus 1, just like that. So it's 4 minus 1 squared is 1. So 4 minus 1, which is 3. So that's what you're going to have at the end. So if you had to cross check, you see that this one was actually a direct question. Okay, so these are some of the questions that you're actually supposed to expect to have or to work with in your syllabus there. Okay, so we shall see. Let's see the other question that is on number 11. All right. All right, so now we are given on number 11 that this is actually a motorboat that traveled 5 kilometers up a stream at an average speed of x kilometers per hour. All right, so write an expression for the time taken in terms of x. All right, so remember this is distance and this is speed in kilometers per hour, and we know that time is equivalent to so this is just an expression for time, which we know is distance over speed. So in this case, already the distance is 5 kilometers, the speed is x, so it's going to be 5 over x. Okay, so remember that time will be measured in what? In hours. So that is 5 over x hours, just like that, guys. Okay, on B we are given that on a return, that is now going back the stream, the boat was now moving at 3 kilometers per hour. That is faster than the upstream speed. Okay, it's actually 3 kilometers per hour faster than this speed, which was at what? At x. So if it is 3 kilometers faster, which means we are going to add. So the question is, write down an expression for the speed of the boat downstream. So if it is 3 kilometers per hour faster, we are going to add. So this is B item 1, so it's going to be x plus 3. Okay, so that will be your speed now in kilometers per hour, just like So you will see that it's just a matter of understanding the information that you're actually given. That is what is important. And how do you formulate the equations is very, very important also, the formulation. So here it was a straightforward thing that we are given, that this is at least 3 faster than, that is we are simply adding. It's not like it's 3 times. If it is 3 times, you multiply, but this is 3 kilometers faster than, so you just add. Okay, so this was our speed. Then what about the expression for time? All right, there is one thing that is not going to change here, which is the distance. Either you're going up or down, the distance is not going to change. We are going to remain with the same distance, in this case of what, of 5 kilometers, the distance here. All right, so that means the time is going to be what? Our time here, remember the expression for time, we say time is distance over speed. So our distance will be 5, and the speed now, it will be x plus 3. This is our speed here, which is x plus 3. So this is now our time in what? In hours. All right, then let's see on number 10b item no, not 10b. Okay, it's item 3 now, item 2. All right, so that's what you're going to have. So this one actually works on this part. That is all right, it's actually another part that we are given. Okay, let me check from this part how these pages mixed now. All right, so it's just a mix of pages. It says number 11, this part. Okay, this page here. Okay, the difference in time taken upstream and downstream was 10 minutes. Okay, so we are given the times, the time that was taken, the difference between. Definitely you're going to see that when he was, or when this boat is actually going upstream, let's indicate this, guys, in a real sense that we know. It is going to mean that when you are going upstream, definitely you are going to take more time than the one that was taken on going downstream, because now going downstream we had more speed. So here there was less speed, which means the time is going to be more. Here the speed was now more, which means the time now is going to be less. So definitely if this is more and this is less, it means we are going to subtract this from this, that is the more time minus the lesser time. And here when going upstream, remember with expression for time, we did this here. This was the expression for time when going upstream, this one for downstream. So what does it mean? From this part, we are going to take this time here for upstream. We say this is the more time, so it is going to be the difference now between. All right, so let's write this as so we said upstream minus downstream must give us the what, the speed that we are given here. I mean the time, sorry, we are talking of time here. So the time that we took is going to give us 10. So the time for going upstream is this one now that we are going to take in terms of x here. Okay, in terms of x, which is 5 over x minus the downstream. When going downstream, this is the time. Okay, we say this is going to be less, which is 5 over x plus 3. This must give us 10. So now that is if you have formulated an equation, and you're now supposed to show that it is going to reduce to this expression. So how is that possible? Okay, so let's just try by all means. Also the other thing, this time is in hours and this time is in what, in minutes. Okay, so let's convert this, because this is hours, this is hours, but this is minutes. So as you can see, these units, they are not the same. So how do you convert minutes to hours? We divide by what? By 60. Remember to convert, we know that in an hour we've got 60 minutes in an hour. So which means to convert now 10 minutes to hours, you're going to divide 10 over 60. Okay, so you can even reduce this to going to be 1 over 6. So you can cross multiply. I don't know what is best for you, or you can combine these two. Remember, we've got x into x plus 3, that's our LCD or the LCM. So we're going to divide our LCM here, divide by what? By x. So x and x will cancel, which means we are going to be left with what? With x plus 3. So it's going to be 5 into x plus 3 minus this denominator here that we have now, divide by x plus 3. So x plus 3 and x plus 3 will cancel, so it's 5 times x, which is minus 5x, and this will be 1 over 6. Remember, we cancel this. Okay, so before you cross multiply, let us just simplify further. Yeah, let us just simplify. 5 times x, this is 5x. 5 times 3, expand brackets, that is 15 minus 5x, everything over. Since we want to solve the equation, or we want to show the equation, we can even expand this. X times x, which is x squared, x times 3, which is 3x, and this is equal to 1 over 6. Okay, so 5x minus 5x, that's s0 there, so you're going to be left with 15 over x squared plus 3x, which is equal to 1 over 6. So at the end, what are you going to do? Remember, we want to show a certain equation, so definitely here we can cross multiply to remove this fraction. So that means 6 is going to multiply what? 15, and this x squared plus 3 is going to multiply 1, so it's 1 times this, which is going to be x squared plus 3. So x squared plus 3x is equal to 6 times 15, which is in this case is 90. So you can transpose this, that's x squared plus 3x minus 90, which is equal to 0. So as we can see, that's the equation that we're being given to formulate in this case. That is what we had here to show that it's going to reduce. So it's just an easy case. You just have to work out the way that you know equations and fractions together. Okay, so that's what we had. And on item 2, it's now to solve that equation that you have reduced. So maybe you couldn't manage to reduce to this part, but this one you have to continue from this, because it's another question, it's a new question that we have, that we must solve that equation that we solved actually. And this is now x squared plus 3x minus 90 is equal to 0. So definitely to solve this, we have to apply the quadratic formula here, where x is equivalent to minus b plus or minus the square root of what? Of b squared minus 4ac all over 2a. So that means applying or substituting our values here, we've got 1 here, and this is our a, this is our b, this is our c. All right, so x is equal to minus b. So make sure this denominator, so this division covers everything. All right, okay, sorry, so that is minus 3 here, plus or minus the square root of b squared, so it's 3 squared again, minus 4ac, so our a is 1, so just put this in a bracket, times c, which is minus 90. Okay, so just put this in a bracket also, everything over 2 times a. Our a in this case is 1. All right, so I always say that it's easier for us to simplify this part first, that is under the square root. So just evaluate these values under the square root. This one, we are going to obtain something like 369. Okay, everything over 2 times 1, which is 2. So by this we can separate now. That's x is minus 3 plus, because we've got plus and minus here, so it's going to be the square root of 369, everything over 2, or another x, now it's a minus, so it's minus 3 minus the square root of 369, everything over 2. All right, so at least that way it's easier for you to even use it on your calculator. So your x here, from this part of the positive, from the positive answer, we are going to obtain something like 8,104, something like that. So you write everything up to the end, or x is equal to, on this one that is a negative, we are going to obtain something like in negative 11,1 04 also, something like that. Okay, so that is what we had, and we are given here to round off these to 3 significant figures. Okay, so to 3 SF, that is the other thing that actually made us to use the formula, because you can't be given this condition where you are using factorization, you see, so you know that you are using quadratic formula there. So to 3 SF, our x is going to be 1 2 3, so that's 8,10 here. 4 cannot change this, or x is equal to minus 11,1. This is 1 2 3, 0 cannot change this, so it will be like that. Remember, significant digits, we are talking about all numbers that are in between the commas. So in this case, it doesn't make sense, like it's like we're having two, but that is what we had, so we just leave it like that. Okay, hence calculate the time to complete the upstream journey, giving your answer correct to the nearest minute. Okay, the time that was taken for the upstream. Okay, remember, upstream, our time was this one that we had here when going up. This was the expression for time when going up, this one, which was 5 over x. Okay, so the expression for time was 5 over x. Okay, so this is item 3. See item 3. Okay, so we said the time for going upstream was 5 over x. This was in hours. Okay, this is what we had in terms of what? In terms of x. But now they are asking for this time, which means we are supposed to find the exact value of time, because now we have got what? The value of x, and we know that our x cannot be a negative. So of these values that we have, our x, the one that we are going to use, is 8,1. Okay, so that is 8,1 here. So if we divide, we are going to obtain 0,61728, something like that. This is the time that you're going to have, and this time is in hours. And remember, we said in an hour we have got 60 minutes. Okay, in an hour. So if it is 60 minutes, what about in 0, whatever that we have here? We are going to multiply by 60 so that our time will be in minutes. So if we multiply by 60, we are going to obtain something like 37,037, something like that, which is now in minutes. So that is where you can now round off to the nearest minute, because remember, the question is to the nearest minute, so your answer is supposed to be in a minute, but to the nearest minute means to the nearest whole number in terms of minutes. So this is our whole number, which is 37. So if you can cross check, the next digit cannot change this number, so it will remain as 37 what? As 37 minutes. So this was the time that was taken to go upstream. Okay, that was it. And last part, which is number 12, it was actually a vector, and we are given a triangle, and all these are straight lines, and OM here, take note of these ratios that we're given. OM is 1 over 3 of OP, so which means, it actually means that OM is 1 part here, and OP is got 3 parts from O to P. That's 3 parts, but we can see that here is 1, so which means we are going to be left with 2, because the whole of this line is supposed to be what? 3. Actually, I explained about these ratios, guys. If you're having some challenges, make sure that you watch those videos from the introduction. Okay, PT here is the same thing, which is 3 here, and the whole of PQ is 4. So here we've taken 3, so which means you're going to be left with 1, of which you just have to know these ratios. And also here, take note, the first ratio is for OP. This one is the whole OP, this 12A here, but this is for OQ, from O to Q. This 4B that we are seeing here, this 4B is for O to what? O to Q. Okay, so take note, it's not for the whole line from O to R, it's from O to Q. So express, the first question is to express as possible in terms of A and B vector PQ. Okay, so what is vector PQ? So since we have got P, we got this ratio, this root here and this root, we can use P to O and O to what? To Q. That is a vector PQ in this case. So this is 12A, item 1, so PQ. That's, we need the root that we are going to take from P to Q. That's PO plus OQ. All right. So this is PO plus OQ. So that's what you're going to have there. And from P to O, as you can see, now we are opposing the arrow. we're going this way, but now it's opposite, so it's going to be minus 12a. Okay, then from O to Q, we are still maintaining the arrow the way that it was going this same direction, so which means it's going to remain as it is, as a plus 4b. All right, so this is our vector PQ. Just leave it like that. Then let's move on to item 2, which is a vector PT. All right, so where are we going to have our PT from? That is a P here to T. So now we can use the ratio, because we've got the ratio here that PT is 3/4 of what? Of PQ. All right, so this one we are given that is 3/4 of PQ. All right, but do we have this PQ? Yes, we have it, because we calculated this one before. So it is going to be 3/4 times, you substitute now the PQ, the vector. This is your PQ here, which is minus 12a plus 4b. So that is what you're going to have. Now this one is simply multiplication. We are simply multiplying 3/4 times minus 12. That's minus 9. So it's going to give us something like minus 9a. 3/4 times 4, this will cancel, so it's going to be plus 3b. So that is our vector PT. So as you can see, this was just an application of the ratios, and the other part, it was just a normal application of what? A normal application of the size that you are given, because already they are there. So that's what we had, guys, on this part. Let's see. This part is now to calculate or to find vector OT. All right, so OT, that means we need a route that we are going to take, and also you must consider that these vectors that you calculated DM, they must also play a part on your diagram. Okay, so first let us locate our O to T. This is O to T, this one. Okay, O to T. Remember, I now have this PT here, this one, this PT. I now have this because I've calculated this PT, and we got minus 9a plus 3b. This is our P to what? To T. So which means OT, we can simply use this one, OP plus PT. Okay, so that's our OT. You have to choose the route that has got everything. So OT is equal to OP plus PT. We say this is going to be PT. Remember, supposed to be a continuation from O to P, from P to T. All right, now we can substitute our OP is there on the diagram. From O to P, we are maintaining the arrow as it is, so it's going to be 12a. PT, we are maintaining also this one, we just take as it is, because already we calculated this, your PT here. This is our PT, so we're going to add this PT, which is minus 9a plus 3b. So it's minus 9a plus 3b. So you can actually expand the brackets here, plus and minus. That's minus 9a plus and a plus, that's plus 3b. So 12 minus 9, that's 3a plus 3b. All right, so this is your vector OT. So you can even leave it like that. Don't worry about factorizing and this and that. Just leave it like that. All right. And then the other part, we are given this relationship effect before we ask to calculate MT now. Before the relation MT, that is item 4. Okay, so let's see which route are we going to take in this case. Which route are we going to take? Take note, the route is from M to T. So we have to start with M going to T. All right, on our diagram. Where is this diagram? Okay, here. This is our M to T, MT, this one, MT. All right. Remember, we have this PT, we have got also this OT. We calculated this OT. So MT, there are so many ways we can use. MP plus PT. We can use MO plus OT. So there are so many ways to calculate this MT. Okay, so in this case, I'm going to use MP plus what? Plus PT. M to P, then P to T, this one, from M to P and from P to T. Why? Because here we are given that this OM is a third of OP. From O to M, it's a third of OP. So which means we are saying a third, which is 1/3 times OP. Your OP in this case is 12A. So if you multiply by 12A like this, you're going to obtain 4A. That is from O to M. This is 4A. Okay. From M to P, it is going to be what? 12 minus 4, which is what? Which is 8A. This is according to the vector. According to the ratio, it's 2. According to ratio, this is 1. If you wanted to use this 2, you are going to say 2/3 times 12A. So this one is 4 times 2, which is 8A. So as you can see, we are obtaining this same answer from M to P. The vector here is what? It's MA. So since we want MT, it's going to be MP plus PT, which is M to P, which is 8A. So M to P is 8A plus P to T, which is this one that we calculated before. Remember, our PT was minus 9A plus 3B. So that's what you're going to have at the end, which is okay. Let's just expand brackets, plus and minus. That's a minus, plus and plus, that's a plus. So it's 8 minus 9, which is minus 1. So it's minus 1A. And writing minus 1A is just like just the same way, guys. It's just writing minus 1. It's just a normal thing. Okay. Just a normal thing that you'll be given. So that's what you had for this vector MT. So you can even leave it like that. And we'll see later on if there's a need for us to use it. Okay. On item B, we're now given that MR is equal to HMT. Okay, so this is another part that we are given for MR, which is equivalent to HMT. So remember, I explained that this H is simply a scalar. So this is simply a scalar that you're having. Okay, so it's H times MT because we want to express OR. But first, find this that you're given, which is your vector what? Your vector MR. So MR here is the first one that you're going to find. So it's HMT. Where is our MT? Remember, this is your MT here, which is minus A plus 3B. All right, so you can multiply by H, which is minus HA, by H here, which is plus 3HB. So this is 3HB. Okay, so take note here, guys. This is 3HB, 3HB, like that. Okay, so this is not our answer. This is MR, but the question needs us to find the vector or the value of what? Of OR. So which means now we have to find a root that is going to connect these two. MR must be part of our answer. Okay, so which root are we going to take from O to R here? From O to R, but using or having MR as part of our root, which means this MR is supposed to be part of our root. So we are going to use this from O to M and M to R to find this OR. Okay, so I'm saying the root that we are going to take to find OR here is going to be what? From O to R. We need the root that we are going to have from O to R. So it's OM, but M to R must be part of the root. So you're going to have, that is why we have to be at this point M, then M to R. So it's, we say it is OM plus MR. So make sure that this part that you are given is supposed to be part of what? Part of your answer, so that your answer is going to be what? Is going to be in terms of what? Of H, which is the constant. So you must include that part that is called H, this one. So OM, we have this from our diagram. So you can simply take this OM, we said it's 4A from that ratio that we did. So it's 4A plus MR. This is your MR, this one. So you're going to combine, which is minus HA plus 3HB. Remember, we said this is 3HB. So you just combine the two. So from the look of things, we can see that A is common here. Vector A is common here. So we can factor out vector A. So if we factor out vector A, it's we are going to remain here with 4 minus what? Minus H. If you remove vector A here, plus 3H vector B. Okay, so this is what you're going to have as our O, as our OR in terms of what? A, B, and H, which is the constant. All right. So let's see the other part so that we can be able now to solve these equations. We are now given on 12C item 1. It is given also that OR is equal to K or Q. So this is another part that you are given about the same OR this time is equivalent to K or Q. All right. So this is what you're given, and they are asked to find OR in terms of K. Okay, OQ, guys, where is our OQ? Let's just trace from our diagram. If we have this OQ, or if we calculated this before, okay, OQ is actually there. So they are saying from O to R, this one, simply multiply by OQ, and already OQ is what? It's 4B. So this is going to be K times OQ, which is 4B. This is vector OQ, all right? So K times 4B, that's 4K vector B. So that will be your new OR, this one. All right. So that's it for this part. The question now is to find or to evaluate OR. Okay, using the expression for OR in B and in C item 1, this one that we have in C item 1 and that one that we had in B, to find the values of H and K. So remember, I told you guys, for you to find the values of H and K, you need the condition where the two vectors are the same. So we are told to use the item B and this item that we just had now. Okay, from item B, guys, this is what we obtained. Let me just write it down. Okay, so this is item 2. So from item B, we obtained that OR is equivalent to this expression 4 minus H into vector A plus 3HB. This is what we obtained from what? From item B. Now from C item 1, this is our OR, but as you can see here, we are given only B. We do not have A. Vector A is not there. So which means if we are to write vector A here, it is going to be like this: 0A plus 4KB. We have added nothing, so it's just like presenting A but with what? With a 0, to mean that there is no A. The A is not there. Okay, so we can write this OR in that manner, which is equal to 0A plus 4KB. We are given 4K, which is 4KB, like this. Okay, so how are we going to find the values of H and the values of K? Remember, guys, I told you that once you've got equal vectors like this, you can equate this part that has got vector A here. This is your vector A, this is your vector A. You equate these two that are being affected or that are affecting vector A, which means what are we equating? We are going to equate this 4 minus H to this 0 here. You equate the constants, the coefficients, these ones. Okay, so that's your first equation. Your second equation, we move on to B. This is our B here, this is our B here. So we equate these constants. It's a plus 3H, so it's 3H, which is equal to 4K. To equate, that is, they are equal, that is to equate. Okay, so I can take advantage here of solving this one because already I'm having one constant or one unknown, which is H. So which means 4 is equal to what? H to this side is going to be a positive. So which means H is equal to what? H is equal to 4. Since H is equal to 4, that means it's going to be easier for me to find now the value of K. I'm just going to substitute here, which is 3 times H, which is 4, is equal to 4K. So I can divide by 4 both sides. So which means our K is going to be 3. So that's what we had. Yeah, this one was easily, guys. So the type of the equation that you're going to formulate, you work with the type of equation. It's not like always you're going to formulate equations which you just solve direct like that. Sometimes we have to apply the normal way of solving simultaneous equations. I think you can even relate from the areas that we did together, from those past exam papers that we did together. It can be much better. Okay, let's see the other part now that we have. This is the ratio now that we are given to find the numerical value of the ratio of MTS to TR. Okay, so this is the ratio of MTS to TR. All right, we need the ratio, the numerical value actually, of MTS to TR. So only what we need is to find MT and find MR. Okay, and find TR. So what you do is that you relate MT, TR. Where are these points or values located? Which line consists of these letters? Okay, MT, TR. These are points which are on the whole line of what? Of MR. This is MR. So now let's relate. Is there any information that we are given before which yet to consist of this MR? Okay, so we have to check on these questions that were being asked before. Is there any part that has got MR? So this is what I'm asking. This is what I'm trying to ask. Okay, so we are going to see that there is this item where we were given that MR is equal to HMT. If you still remember from those information that we were given, there was this part which were given like this. Okay, so from this information, I'm actually okay here. So there we got MRMT. So that is how you find out. So it was given in terms of h, but now we just determine the value of h. We know that our h is what? Is 3 is 4. Okay, our h is 4. Remember our h, we calculated and we got 4. So we can replace this now to say MR is equivalent to h, which is 4 times MT, like this. So what does it mean? It means MR consists of 4 MT. This MT, this one that we see, this one. This is our MT, this one. This is one of it. We just have one MT here. But this MT, which is one that we see in the whole of this line M to R, this one, which is MR, there are 4 of them. There are 4. So here we have one MT, this one that we see. But we are saying all this line, there are 4. So which means how many are left between T and what? Between T and 3 and R. So it's going to be 4 minus what? 4 minus 1, which is actually a 3. So that this will give us what? A 4 at the end. So if you add 1 plus 3 is going to be 4. So which means MT, it's one part. TR, it's 3 parts. But the whole of MR, this one, the whole of MR is what? It's 4 of these MT. Okay, so this is what we simply have. So here we can now express this ratio because we can clearly see our MT to say, okay, this is my MT, which is 1, all right, as to TR, this is my TR from T to R, which is 3 parts, so it's going to be 1 as to 3. So to answer this type of equation, you have to relate back on the information that you were given. Is there any part that consists of these letters that you are given, but as a single ratio? Then you express the answer in terms of how you are given. If it was asked like this, MT over TR like this, you write it as a fraction 1 over 3. If it is given this way, you answer the way that they have given you, or the way that they have presented the ratio to you. So that's what we had, guys, from this question paper. I think we had a lot that we learned from this part. If not, then we are going to meet again on another class or another question papers where we are going to be revising more past exam papers. But for now, that's it for Mason African Motives, working on O-level mathematics, past exam papers and revisions, and everything that we have for actually for Maths O-level. That's what we got here, guys. So that's it till we meet again.